What's going on, YouTube? Welcome back to the channel, guys. Hope you are doing well. Man, I have something special for you guys today. For real. This is dope. Right? This has been the most demanded piece of content I've received from you guys for the last 2 years. How to build Uber with SwiftUI, and we got it ready to go right now. 4+ hours of content, 14 modules coming your way absolutely free. Right? Because that's what I do. That's what I do for you guys, because I love you guys. So this is going to be absolutely amazing, guys. I hope you're ready to get started. Let's go ahead and check out a demo of the app. So this is what the home view of the app is going to look like. This is what the user is going to see when they open up the app for the first time. We're going to also go over how to request access to their location and stuff so that we can ultimately display their location on the map, which is what we see happening here. And another really cool feature we're going to implement that makes the app a lot more dynamic is the ability to follow the user's location and update the map view in real time. So let's take a look at what that's going to look like. I'm going to go to features and I'm going to change my location in the simulator. And you guys will notice that it follows the user's location in real time and centers on the user's location automatically as well. So that makes the user interface a lot more dynamic, and it's some really cool functionality to have in this application. So let's continue on with some more of the functionality of the app here. So if I click on this like where to guy right here, it's going to bring up like a location search view. And you guys notice that it stores past results that I've searched for. And I can exit out of that view with this sort of dynamic floating button here, which is really, really cool. The animations are super smooth. The functionality is flawless, as you can see. And something that's really cool about this search feature is that it has autocomplete, and we can also search for generic things like coffee shops, gas stations, restaurants, stuff like that. So for example, if I just type out coffee, it's going to bring up a bunch of coffee shops nearby to me just from using the word coffee. And you guys can see that this updates in real time, right? Which is absolutely incredible. And it doesn't stop there. It prioritizes these coffee shops by either the most relevant to the search term or how close it is to the current user's location. So this is absolutely incredible functionality here, guys. Let's go over what would happen if I click on one of these locations now. So I'm going to click on this place called Coffee Lovers, and you guys are going to see that beautiful animation there where this ride request view sort of animates up like a nice bottom card. And you're going to see the map view go through some nice animations there as well, where it draws a route to my users to the destination location. It drops a pin at the destination location. And then this view right here has a bunch of information about the trip, which is absolutely incredible, right? We see where we're going, the pickup time, the drop-off time, and that's actually all calculated relevant to the trip and the current time. Like right now it's actually 7:18, and it would actually take me however many minutes this is to get to my destination. This is real data here, guys. It's not dummy data. And then we also have this awesome ride types selection option or feature where we can select a different ride type, Uber Black, Uber XL, or Uber X. We're also going to introduce a pricing model. And once again, those aren't just random numbers. That's actually a pricing model that we're going to develop that's relevant to where the user wants to go. And then it also has this beautiful animation for when I want to select a ride. So if I want to get out of all this stuff, I just go up to the top here with my floating action button, which is dynamic. And I click that, and you can see the functionality is different, right? It's going to remove all the stuff from my map view and just recenter on the user's location. And just so you guys can see that this is actually dynamic data, let's go ahead and try to go to a gas station. And you guys can see here that it populates with different information here, different prices, different times, different location name, and all that good stuff, right? So this is absolutely incredible, guys. And something else to note here is that I can also obviously just search for real addresses, right? So I can go here and just type 123 Main Street or something. And it has, obviously, it's not just a generic location searcher. You can search for specific addresses as well, anywhere you want to in the world. So the functionality for this, guys, is A1, man. Like, this app is going to be awesome. It's all built with SwiftUI. And guess what? This isn't anywhere else on the internet. Nobody's done this with SwiftUI. I'm the first guy to do it, and I'm bringing it to you guys exclusive to my channel. So hope you guys enjoy. Like I said, we got 4+ hours of content ready to go, 14 modules. Oh, and guys, I forgot to mention, last but not least, we also have dark mode support, dude. Like, what? This is so dope, man. Like, full dark mode support. Like, check this out, dude. Like, that's just absolutely beautiful. You guys are going to learn how to do some absolutely amazing things here in this app. It's taught to you by a meta engineer. I'm a high-level pro. I'm going to teach you how to code this like a pro, get you better at coding. We're going to build something super fun along the way. Hope you guys are excited, man. Let's dive into the code now. Bam! Last thing before we get started is where to find the source code. So you guys are going to head to my website at stephancodes.com if you want access to the source code. I provided a link in the description to this video, and then you're going to go to the YouTube courses section. So to get access to this page, you do have to be a member at my site. You can sign up on the plans and pricing section. Just go ahead, and if you want access to this, go ahead and become a gold member. And for just $10 a month, you guys get access to all of the current and future YouTube courses that I'm doing for just that $10 a month. I also give you access to the GitHub repositories for these projects so that you have access to all the updates, all the bug fixes, feature improvements, feature requests, all that stuff. Lifetime access, guys, for just $10 a month, and you can cancel anytime. So make sure you check that out on my website at stephancodes.com. Once again, this YouTube courses section requires a gold membership plan. So that's just $10 a month. Make sure you guys check it out. Links in the description. Thanks, guys. Let's go ahead and finally get started. I know you guys are waiting. Thank you for being patient. Let's go. So to start things off, we're going to create a new Xcode project. We're going to select app and then hit next. And I'm going to call this Uber Swift UI tutorial. And just make sure that SwiftUI and Swift are selected there. You don't need core data or tests. So we're going to go ahead and hit next and then hit create. And as always, if you guys have been following me for a bit now, you know I like to set up my project directory. So that's what we're going to start with. We are going to close out this right side menu bar, and we're going to go over here to the left in our project navigator and create some new folders. So first thing, you can either right click and hit new group, or you can use the shortcut, which is just holding Command, Option, and N. And we're going to create 5 groups. Okay, the first one is going to be called app. The second one is going to be called core. The third one is going to be called extensions. And then this guy is going to be called managers. And the next one is going to be called models. Awesome. Okay, so first thing, guys, let's go ahead and just delete this content view so we can move that to the trash. And we're going to go up to our core folder and create 2 more folders there. So 2 subfolders in the core folder. First one is going to be for view models, and the second one is going to be for our views. And under this views folder, we're going to create a home view. So select new file, and then we're going to create a SwiftUI view. Hit next, and we're going to call this home view. And the next thing we are going to do is go to this app file. And since we deleted this content view, it's not going to be there anymore, or it's not going to recognize it. So we're just going to replace that with home view. And then to finish this off, we're just going to move this app file up into our app folder. So now our project is nice and organized. And we're going to be getting started with what you see here on the screen, just simply displaying the user's location. And we're going to go over how to get the user's location and ultimately display it in a map view. So SwiftUI actually does have its own map view component, but it does not have a lot of capability. And for what we're going to be doing here with this app, we need to do certain things like generate polylines and add custom annotations to our map. And unfortunately, with the SwiftUI map component, it doesn't really have all of that capability just yet. So there is a workaround, and that's what we're going to be doing. So we're going to go and create a new file in our views folder, and we are going to make this a Swift file. And we're going to call this Uber MapView representable. So for those of you who are familiar with this UI view representable protocol, it essentially, or for those of you who aren't familiar with it, it essentially allows us to create a view using UIKit. and represent that view in SwiftUI. And that's what we have to do for this application for our map view, since it is going to be a little bit more complex. So let's go over how we're going to do this. So we're going to create a struct, and it's going to be called Uber MapView representable, and it's going to conform to this UI view representable protocol. And we actually need to import SwiftUI for it to recognize that. UI view representable, and let's just wait for my autocomplete to do its thing. Oh, I said UI view. UI view representable. So let's look here. It says a wrapper for a UI kit view that you use to integrate that view into your SwiftUI view hierarchy. So we're going to see how this works here in just a second. So to start this off, I'm going to say let MapView equal MK MapView. So this is the UI kit MapView component. So we actually need to go up to the top here and import MapKit. And we're going to use this UI view representable protocol to configure our map view now. So we need a function called make UI view. And this does exactly what it sounds like. This is where we actually make our view and configure it so that it can be represented in our SwiftUI app. So we're just going to add a couple parameters to our map view, or add some configure it here essentially. So we're going to say map view. We're going to say .isRotate enabled equals false. Map view .shows user location equals true, and map view .user tracking mode equals .follow. And then we also need another function called update UI view. So this function is in charge of actually updating the view when we want to do stuff to it. We're going to be using this function quite a bit to update our map view in certain situations, right? Like for example, when the user selects a location, we're going to want to update our map view to show a polyline to that location, get directions to that location, all of that good stuff. Sorry guys, up in this function, we actually need to say return map view. Awesome. We're not going to do anything in this update UI view function just yet. And then we need one more function. So these are all part of this UI view representable protocol. They're requirements that we have to implement so that SwiftUI can figure out how to represent this UI kit view inside the SwiftUI view hierarchy. So we need one more, and it's called make coordinator. And this is going to return a custom class that we're going to create right now called a map coordinator. Coordinator. Cool. So let's go ahead and do that now. We're going to create an extension on Uber MapView representable, and then we're going to create a class here called map coordinator. And I'll explain what this map coordinator is going to be responsible for doing in just a second. It's going to conform to two things: NS objects and MK MapView delegate. We need access to the parent in this class, so we're going to say let parent equal Uber MapView representable. Then we're going to say init with parent, which is Uber MapView representable, and we're going to say self.parent equals parent and super.init. So we'll go over what this parent and sort of coordinator relationship is in just a second. Really quickly, to make these errors go away, we actually have to go up to the top here and say return map coordinator. Parent is self. Okay, so now we can actually go ahead and use this map view representable back inside of our SwiftUI view. And the beauty of this is that we can conform to this MapView delegate protocol that has all of the functions that we need in order to perform the complex stuff in our map view, like generating directions from location to location, generating polylines, and all that stuff. We can't do that with the native SwiftUI MapView component, so we have to do it this way. So back in our home view, you'll see that we can now go here and just drop this in. We can just say Uber MapView representable right there. And let's give our preview a second to load, and we're going to see a map view showing up. So that's awesome. Let's do one more thing here, guys, and say .ignores safe area. And that's going to make our map view just stretch to fit the entire screen, which is what we want. And now we're going to go over how exactly we can display our user's location in the map view. So to get this started, we're going to go into our managers folder and we're going to create something called a location manager. And this is going to be responsible for requesting the user's location. You guys have probably seen this in apps before that ask you to give the app permissions to access your location. That's what we're going to be going over how to do here. So in this managers folder, go ahead and create a new file. It's going to be a Swift file, and we are going to call it location manager. And let's go over what we need to do to set this guy up. So first thing, we need to import core location. We're going to create a class called location manager, and it's going to conform to NS object and observable object. And that should be good for now. So now let's actually create our location manager. We're going to say private let location manager equals CL location manager, just like that. And then we are going to initialize this class. So we're going to say init, and we're going to configure our location manager now. So I'm going to say location manager dot desired accuracy equals KCL location accuracy best. So this just gives us the most accurate possible location for our user's location. And then we're going to say location manager dot request when in use authorization. So this is the function that we need to call in order for the app to actually request the user's location and all those permissions. And then we're going to say location manager dot start updating location. So this function will actually, start updating the user's location so that we can access that user location. Okay, so now in order to initialize this, or in order to get this, init to run, we have to initialize this location manager somewhere. And we can do that in our Uber MapView representable file. We can just say let location manager equal location manager, and just initialize it there. And if you guys were to run the app right now, let's just go ahead and do that. You're going to see that we actually don't get that window popping up to request the user's location. And that's because we need to modify something in our info plist. So if you look at your console, it's going to give you the error that you have. So it's going to say somewhere in here that, right here. The app's info plist must contain an NS location when in usage description key with the string value explaining to the user how the app uses this data. So this is a requirement from Apple. We just pretty much have to tell the user why exactly we're going to be requesting their location. So if you guys go up to your project name up here and go to this little menu that you see, and then you go to the info section, this is our info plist, and we're going to be adding a property here. Let me just go ahead and grab it real quick from my completed code. Okay, so I see it now. We can go and type it out ourselves. So just go highlight any one of these fields with your mouse and then click on the plus button. And you're going to say privacy. Just start typing this out. And it's case sensitive, guys, so make sure you capitalize all of these things accordingly. So it's privacy with a capital P, space, dash, space. And then it's going to be location when in use uses description. So the autocomplete should fill that out for you. And then in this string guy, you can just say please allow us to access your location to find you nearby drivers and rides, something like that, right? So now that that's there, we can run our application again. And you guys are going to notice that it gives us that little pop-up window asking for the user's location. Don't hit the button just yet. I want to do something back in our map view so that once we hit this, it will automatically update our user interface to show the user's location and actually zoom in on it. So we're not going to hit anything just yet. If you did, it's okay. I just want to show you guys how this works. So back in our Uber map view representable, we can actually go down to our map coordinator class, and we're going to see where this coordinator starts to come into play. So we are going to have access to a function here. So go right outside the init and just start typing out did update. So this is a delegate method that tells the delegate that the location of the user was updated. So we pretty much just want to access this user location and create a region on our map view so that we can zoom in on that region and display the user's location. So let's go ahead and figure out how we're going to do that. Give me just 1 second. Let me get my code opened up. Okay, so we're going to create a region here. We're going to say let region equal MK coordinate region, and just open up some parentheses. And you guys are going to see this option with a center and a span. So this is the one we're going to select. So we have to pretty much just give it some coordinates and a span, basically the zoom that we want on that particular coordinate. So I'm going to indent this a little bit just to make it a little neater, just like that. And we're going to create a CL location coordinate 2D here. And it's going to ask us for a latitude and a longitude. So we can just get that from this user location input parameter we have in this function. So we can say user location dot lat, or sorry, dot coordinate dot latitude, and then user location dot coordinate dot longitude. And then the span is going to be an MK coordinate span right here. Open that up. Latitude delta is going to be 0.05. Longitude delta 0.05. Okay, awesome. So now that we have our region here, we can go ahead and say parent.mapview.set region. Region animated is true. So this isn't going to work just yet. There's going to be something we need to do back in the location manager. I just want to give you guys a brief explanation of how exactly this works, because a lot of people get confused with how this MapView, or sorry, this UI view representable protocol works. So these, like I explained before, this function is in charge of making our map view. So we already see that on the screen. So we know exactly what this is doing, right? We haven't done anything with updating our UI view yet. That's going to come later. But the part I want to explain is this map coordinator. So this map coordinator class is going to be the thing that conforms to the MK MapView delegate protocol. If you guys have never worked with UIKit, the concept of protocols and delegates is going to make zero sense. So I highly recommend looking up some information about how protocols and delegates work, because, you know, some UIKit functionality is obviously still evident in SwiftUI. But essentially this MK MapView delegate gives us a bunch of functions that allow us to do stuff on our map view, or in this case, do stuff with our user location. So all this code up here knows nothing about the MK MapView delegate, right? It's just this map coordinator. So this coordinator is basically like a middleman between our SwiftUI view and our UIKit functionality. So we need functionality from the UIKit framework, and then we have access to our parent right here, which is our Uber map view representable. And we essentially want to do stuff to our map view, but we have to do that stuff from, to our map view from this map coordinator class. So this parent is how we're going to communicate between our map coordinator and our Uber map view representable class. And we can see that right here where we say parent.mapview.set region. Okay. So that's sort of that relationship there. We're going to be using this class a lot. So if that doesn't make sense just yet, it is going to become clearer as we go through more of this code and develop more functionality here. So we're setting the parent's map view using this code that we get from the MK MapView delegate. So one more thing we need to do back in our location manager is set up some delegate functions here as well. So I'm going to say extension location manager, CL location manager delegate. And we're going to have a function here that actually grabs our user's location or updates the user's location in the app. So we can say did update locations right there. And we pretty much just want to make sure that this locations array isn't empty. So I'm going to say guard locations.isEmpty else return. And then we're going to say location manager dot stop updating location. So I'm going to go over why exactly we do this in just a little bit. One more thing we need to do is say location manager dot delegate equals self. And then in our Uber map view representable, we have to set the delegate for our map view as well. So we go here and say map view dot delegate equals self. So now let's actually go ahead and run this code. And that's kind of annoying. Build failed. Let's see. Oh, guard locations dot is empty. So let's run this one more time. Location manager. Oh, we need to say super.init here. Let's see, one more error. Cannot assign. Oh, here we need to say context.coordinator. So I'll explain that in just a second. I just want to go ahead and see if once we allow our location to be accessed, if it updates our map view. So let's go ahead and say allow while using app. And you guys will see beautifully right there that it sets our location and zooms in on that user location. So the simulator location defaults to, I think, the Apple headquarters or something like that, or maybe I have it set to something else. I believe I have it set to something else. But if your location's showing up in California on the simulator and it's confusing you, that's why. The simulator has its own location framework. But anyway, we accomplished that successfully. And let me just go ahead and give one more brief explanation of how all of this stuff works. So we have to set the MapView delegate protocol or the property to context.coordinator. And this is another piece of this puzzle where the coordinator comes into play. So our coordinator is this guy right here. We're returning the map coordinator. And we have this function that's a requirement from this protocol to make a coordinator, right? So like I said before, all of this code right here in the UI view representable protocol doesn't know anything about the MapView delegate. All of that stuff is handled through the coordinator. So we have this context object here that gives us access to this coordinator. And this is where we make the coordinator. And then this is the coordinator itself down here. I just said coordinator like 50 times, but our coordinator is going to be the thing that conforms to this MapView delegate protocol and gives us all of that functionality that we get for free from the MK map kit. And then, like I said before, we have access to this parent property, which is our Uber MapView representable class. And we can communicate from this coordinator that has all the MK map kit functionality back to our Uber representable or Uber MapView representable class, and then do things like update the region for our map view. So we did some stuff in our location manager too that involved a delegate. So basically this is a function that gets called when the user location updates. So why did we write these two lines of code? Well, it's because when you say start updating location, so I'm just going to add a print statement really quickly here. I'm going to say print locations.first. And I'm going to comment this line of code out and run the code again. So you guys are going to notice that in the console, we're going to repeatedly get multiple print statements giving us back the user's location, right? You see it's constantly updating the user location, or it did it like 3 times. But basically once we start updating the location and we get it back from the user, we want to just stop updating it right there. We're going to then handle all of our location updates through our map view. We don't want to keep accessing the user's location through this location manager. The purpose of this was just to request the permissions from the user, grab the location one time, and then our map view is going to handle the rest of the location stuff. So I'm going to uncomment that line of code and just tell it to stop updating the location. And then back in our Uber map view representable, where we conform to this protocol function here, this is where we're going to handle all of our location updates. We can't ask the user for their location through the MapView framework. We have to do that through the CL location manager. And something that's pretty cool is if you guys now go and click into your simulator and then go to features and then go to location. I have a custom location right now, but for example, if I say Apple, it's automatically going to move my user's location to Apple, and then follow the map view region will automatically update, right? And that's because we have this code here. And you guys can see what I'm talking about now, where like we are getting the user's location back constantly. That's because we haven't run the code since I told it to stop updating. If I were to run it again, you'll notice that if I change the user's location, it's not constantly giving it back to me. There might be some apps where you want to do that, where you want to constantly ping for the user's location. But in this case, we don't really want to do that. So now, let me see. Let me add that print statement back. Sorry, guys. Print locations dot first. And let me run this one more time. And we're going to see how many times we get this print statement back when I update the user's location. Right, so now it's 2. That's not bad. I'm going to go to click into my simulator, go to features, location, say custom location, and I just have it as 37.41 and negative 122.1. Go ahead and hit OK. And you guys notice that we don't get any print statements back about the user's location because, like I said before, we told the location manager to say, hey, once you get this once and it updates, just go ahead and stop updating it, because that's just going to cause us problems in this app, and it's honestly just unnecessary, and it's going to drain the battery of your application and just make it overall more inefficient. So I know that was a lot, guys, but that's the most difficult part of this setup here. Everything else is going to flow pretty smoothly. So now that we have our user location showing on the map, we're going to get into how we can actually start searching for locations and then start to request rides. Really quickly, I just wanted to show you guys the pro version of this app. It's going to contain way more features than what we cover here in this YouTube version of the app. And I'm just going to go ahead and give you a quick demo. The completed code is going to be available on my website at stephancodes.com. And I'm also going to be making video tutorials for all of the additional features as well, which will also be available on my website. Let's just go ahead and check out a quick demo. So here I have 3 versions of the app open. This is a passenger version of the application, and then these 2 simulators have drivers logged into the app. So first thing, we're going to get user authentication as well. Users can sign up and get authenticated. And then you can see here in the passenger version of the app, I still have the where to option for where I want to go. But one of the super cool features that we're going to be able to see is that we can see drivers on the map here. And these drivers are only loaded if they're within a certain radius of the user. So we have some geolocation functionality of there as well to optimize performance. And something else that's really cool is you can see the driver's locations update in real time. So for example, if I go over to my app all the way on the left here and I adjust my location, let's say like 4.2, you guys will see that the driver's location moves in the passenger side of the app, and his, obviously the driver's location moves for his side of the app as well. So let me just move it back so you guys can see that one more time. So I'm going to move this driver's location. So pay attention to this guy right here. You're going to see it move back to that spot in real time as the driver's location updates from his side of things. You're also going to have this really awesome side menu. So it's just going to display some money about the user. And then you're also going to get this awesome driver registration flow. So everyone just registers as a user. And then just like in the Uber app, you're going to be able to go and further register as a driver from there. And, you add a profile photo, you add a vehicle and all that good stuff. And that's how you register as a driver. And then the side menu becomes a little different, right? So this is a registered driver. You can see that he can enable or disable his active status to say, hey, I'm requesting or accepting ride requests. And then this is another version of the driver. And you guys can see the difference between dark and light mode here as well. So let's actually go through what it looks like to request a trip really quickly. So I'm just going to go ahead and go to Coffee Lovers, and this is exactly what we're going to be doing in this YouTube version, but in this we're going to take it a step further and actually be able to request a ride. So you guys can see here, this is another really cool feature. The ride request will show up in the driver version of the application, and you can accept or reject it. But you guys notice here that nothing showed up, and that's because it has sort of a cascading system for how it requests rides. So it goes to the closest driver. If that driver rejects it, it goes to the next one, until there are no more drivers nearby. So if I were to accept that trip, you guys would notice that it draws a route from the driver's location to the user's location. and says, hey, pick up Stefan at Apple campus, and it's going to take you 10 minutes to get there. And here's the amount you're going to make for the trip and the amount of time the trip is going to take. So that looks really good, and you can cancel the trip at any time. And something else that's really cool is the app is going to notify you when the driver arrives. So let's go ahead and take a look at what that's going to look like. Really quickly, guys, one more thing. Let me just adjust the driver's location, say like 3.9, and you guys will be able to see him getting closer and closer to the user, right? So if I say maybe like 3.8 and 122.05, you guys are going to see him get even closer, and you see the map view automatically adjusts and zooms to fit the driver and the user's location exactly the same way we see in Uber. And ultimately, my passenger is at Apple. So if I go all the way to Apple from my driver's side of the app, you're going to see him like slowly arriving, which is really cool. And then in just a second here, you're going to see like a pickup view show up, right? So you guys can see here, let me get this guy out of the way, or I'll just keep it there, that you now have the option to pick up the user, and then this guy, these two, notification views, so to speak, are different. Hey, your driver's here, and this one just says, hey, you've arrived to pick up the passenger. It tells you where you're going, what kind of car the driver has, their license plate number, their rating, all this incredible stuff. And once again, guys, this is the completed pro version of the application that's going to be available on my website at stefancodes.com. So let me just go ahead and cancel this trip. You guys will notice that it removes everything for both sides of the app here. And let me just take this driver all the way back to where he was before. And let's see if I just like zoom out. You guys will see both drivers showing up there as well. And if I want to go back to coffee lovers, let me just show you guys what that would look like. You guys notice that it goes to the next driver now, right? Because he's closer to this user now. And if I reject that, then you guys can see that it goes to the next closest driver, which is absolutely incredible. So that's going to be pretty much the bulk of it. You guys are also going to get these really cool features like this settings page where you can add saved locations like a home and a work location. You can sign out from here, manage some notification settings and all that cool stuff. And another great feature is you can see the trips that you have taken in the past with what drivers, where you went, and all of that amazing stuff. So that's going to be the completed version of the app, guys. That's just a quick demo. Tons of amazing features that really, really bring this app to life and bring it to that production level. And once again, it's going to be available on my website. Not there yet. Make sure you guys subscribe to receive notifications for when it does become available. Anyway, guys, let's go ahead and get back to the code with our project now. So in this module, we're going to be adding some user interface components to our map. So I'm going to go ahead and show you guys the completed version of the app and show you what we're going to be doing in this module. So we're going to be adding this like where to view. And when the user clicks on that, it's going to open up this location searching view. And the user will be able to, type in some stuff into this text field and have it display some nearby locations with this awesome local search completer we're going to be implementing later on. We're also going to add this action button to help us transition in between different states. So for example, right now in the completed version of the app, you have this awesome side menu. And then if we were to go into this location search view, we notice that the button changes the image and it changes the action of it as well. So we're going to be going over how to get started with that stuff in this video. And for reference, guys, I'm always going to keep the completed version of the app in dark mode, and I'm going to keep our version of the app in light mode. So really quickly before we get started, I noticed that I didn't do this directory properly. I just added views and view models. So we're actually going to add another folder here, and we're going to call it home. And then we're going to take these two subfolders of view and view model and add it there. And then we're going to create another folder in our core folder called location search. And I'm going to start off by creating this location search activation view. That's what we're going to call it. Before we do that, let's go ahead and create two more folders for this. View model. And in this views folder, in our location search folder, we're going to create a new file, and it's going to be a SwiftUI view. And we're going to call this location search activation view. And the reason I call that is because, clicking on it sort of activates this like location search mode. So let's go ahead and see what we're going to do to build this. It's going to be a super simple view. I'll keep it up here for reference. And this is what Uber looked like in one iteration of its app. So we're going to just be pretty much following that exact layout. So this is going to be an H stack. And we're going to have this rectangle here. That's what we see right here. And it's going to be super simple. We're just going to say .fill is going to be color .black. .frame is width of 8 and a height of 8. And then we're just going to give it some horizontal padding. Just like that. We're going to create a text component. It's going to say where to. And we're going to give it a foreground color of dark gray. Or we can just say color.dark gray. And then we are just going to create a spacer there. So that's going to shove it over to the left. And then we're going to give it a background of this rectangle here. And we're going to apply a shadow to that background as well. So first off, let's go ahead and give this a frame. We're going to say width is UI screen, .main, .bounds, .width, minus 64. And the height is going to be 50. And then .background. And just go ahead and hit enter in between those parentheses, and we're going to create a rectangle .fill color .white .shadow with a color and a radius of .black, and the radius is going to be 6. So that's a super simple view, and now we're going to go over how to drop this into our map view. So I'm going to go back to my home view. And we need to basically place this on top of our Uber map view representable. And in order to do that, we're going to utilize a Z stack. So Z stacks help us put things on top of each other. And all we need to do that is we can command click onto this guy and just say embed in Z stack. And then we can literally just go ahead and go here and say location search activation view. And we should notice that guy come up nicely. So it shows up in the center of the screen, and we don't want that. Luckily, Z-stacks come with alignment properties that allow us to align things really easily. So we can just say alignment is .top. And that's going to shove this all the way to the top, and that looks pretty good, but we are going to want some padding on this guy. So I'm going to go ahead here and say .padding .vertical, and we could give it, I think, like 72 pixels of vertical padding. Actually, we can just say top. We don't need to put any padding on the bottom. And that looks really good there. And then next up, we're going to be creating this map view action button. So I'm going to create a separate file for this. You guys might think, hey, this is a really simple button. Why do we need to create a separate file for it? And that's because we're keeping scalability in mind here. This home view is going to get really complex with all of the functionality that we're going to have. So the more subviews you can extract and place into different classes, the better. It just keeps your view super, super neat and clean. And it makes your code a lot easier to work with and maintain. So we're going to create another view in our home view folder. It's going to be a SwiftUI view. And we're going to call this map view action button. Okay, and this is going to be a super simple view as well, guys. It's just going to be a button with an action and a label. Leave the action blank for now. And our label is just going to be an image with a system name of line.3.horizontal. Then we're going to say .font.title2. .foreground color is .black. .padding, .background is .white. It's going to have a clip shape of a circle, just like that. And then we're just going to give it a shadow as well. But let's wait for our preview to load. Okay, so that's looking pretty good. Now you're going to see if we give it a shadow, it's going to just help it stand out a little bit more. So we can say .shadow with a color and a radius of .black. Radius is going to be, let's make it 6. And you can see now that that shadow gives it a little bit more dimension, and that looks really good. We are going to want to align this to the leading edge. And a really simple way to do that is just to go here and say dot frame max width is going to be dot infinity, and alignment is going to be dot leading. Okay, so you guys are going to notice that just shoves it all the way over to the left side of our screen. And then if we go back to our home view, we can now drop this in here. We can just say MapView action button. And let's take a look at how our home view is looking now. And that should look pretty smooth and awesome. That looks great. We just want to give this a little bit of padding. So I'm going to say dot padding dot leading. And that's going to just shove it over there a little bit. And then maybe we could give it some padding on the top of like 4. We don't really want it to get in the way of our location search activation view. So that's a quick win right there. In the next module, or to continue on with this one at least, we are going to go over how to implement this location search view. And we're going to get to the actual functionality of this view a little bit later. All I want us to do is build out the UI for this, and then to end this module, we're going to go over the presentation logic for that. And what I mean by presentation logic is how to tap on this and show it, and then how to click on this button and change the state of that button to exit that view and take us back to our map view. So next up, we're going to be creating the user interface for this location search view, and then we are going to go over the presentation logic for how to show it and how to hide it or get out of it. So let's go back up into our location search folder and create a new view file. It's going to be a SwiftUI view, and we're just going to call this location search view. And we're going to start by implementing this header view, and then we're going to implement the list view of all the locations. So this is going to be inside of a VStack. I'm just going to do some comments here to lay this out. So we're going to create the header view and then the list view. So our header view, first off, we need this like cool little like indicator view that says like, hey, this is the current location and you're going to this destination location. That's going to be pretty simple. We're going to wrap this all inside of an H stack, and then within that, we are going to have a V stack. And this H stack, this is going to be the entire view, right? This is going to be laid out horizontally, but this view right here, itself is a V stack. So we're just going to create a circle, say dot fill color dot system gray 3 dot frame width and height, just like that, and it's going to be 6 by 6. Then we're pretty much going to do the same. We're just going to copy and paste this right here. We're going to change this guy to a rectangle, and we're going to change this guy to a rectangle as well. Okay, and then we're going to make this, the next up is the little rectangle that goes in between the two things. And we are going to say the fill is color.system gray 3. The width is going to be 1, and the height is going to be 24, just like that. So you can see that this is already starting to come together really nicely. And then we're going to keep the dimensions on this guy the same for the last rectangle, and the fill is just going to be dot black, just like that. And you guys notice that that gives us that awesome little indicator view, just a nice touch on the user interface. And then we can go ahead and just fold this. So you guys can command click on that last bracket and just hit fold. And now let's keep going with our, the header view. So now we are going to create another VStack, and this is going to be for our text fields. So I'm going to say text field, and the placeholder is going to be current location. And the text component, we actually need to create a binding property for this. So let's just go ahead and create 2 of these because we're going to have 2 text fields. Sorry, we need to create a state property. So we're going to say state private var, start location text, blank string, at state private var destination location text equals a blank string. So now we can just go ahead and pass this in. This is the start location text. And then we're going to give this a frame, just height of 32 pixels. Dot background is going to be color parentheses dot system grouped background. Padding of dot trailing. And that should be good. And then we can just copy and paste this code for this text field. And this is going to say where to. And we're going to replace the text property to destination location text. And we are going to make this color of dot system gray 4. And oh, so that's my bad, guys. We need to unfold this. This is stacking vertically. We actually want to take all this Z stack code and cut it, and we're going to place it in the H stack right here. And that's going to align them horizontally now. So you can see why we set that up as an H stack. Okay, so that looks pretty good. Ooh. Don't say background style, say background. That's my bad. That's why the background color is not showing up. Okay, that looks great. Now on this H stack, just double click on the starting bracket and we're going to give it a padding of dot leading. Awesome. Okay, we could actually just make it horizontal just to give it even padding on both sides. So that looks great. Now we can actually command click on that bracket and hit fold. Awesome. Okay. Next up is our list view. So this is going to be pretty simple. It's just going to be a scroll view. You can see it's a scrollable list right there. So we're going to say scroll view vstack. Our alignment is going to be dot leading. And let's see. Now, let's just make a for each loop. We're just going to add some dummy location cells. Like we are going to be actually, adding the functionality for this search completer later on. So we display real results, but for right now, we're just going to display some dummy data. So we're going to say for each 0, and you can just do like 20 dummy cells, ID \self. And then we can just say bracket underscore in. And what we need to do now is actually create like this cell. So it's going to have this image and then, a title and a subtitle. We are going to create a separate view for that. And once again, guys, creating all these separate subclasses just to keep the code clean. You will really thank yourself for doing that as your code starts to get, or your project starts to get really big. So we can call this location search results cell. And let's go ahead and see how we're going to create this. It's pretty simple. It's just going to be an H stack with an image and a title and a subtitle. So let's get started with that. We're going to say H stack image system name map pin dot circle dot fill dot resizable dot foreground color of dot blue dot accent color of dot white, and then we're going to say frame with height of 40 by 40. And then we're going to create a VStack for this title and subtitle. So that looks really, really good right there. And here is our VStack. And we're just going to create some text. It's going to say like Starbucks coffee or something, and then we'll say dot font of dot body, and then text like 123 Main Street, Cupertino, California, or something like that. And you're going to say dot font dot system size of 15 dot foreground color is dot gray. And you guys notice our alignment's a little bit off right here. So on our VStack, we can just go ahead and provide it with an alignment of .leading. And that's going to line that up really, really nice. And then in that VStack as well, guys, just go ahead and say divider. And that'll give it a divider. And that looks really, really good. And now, let's see. I think that should be good. Let's just give it some padding on the leading edge as well. Oops, .padding, .leading. And that's going to give us some spacing on that leading edge right there. So that looks great. We are going to want some more padding between our text and the image and between our text components themselves though. So here we can say .padding, .leading on the VStack. And maybe let's just do like 8. And then we could say .padding, .vertical. Let's see, vertical of 8 pixels as well. And that looks really good right there. Okay, so, and really quickly guys, to get the spacing between the text components, just say spacing of like 4 pixels. So they're not so bunched up and close together. And that looks absolutely incredible. Now let's go back to our location search view, right? And we're just going to drop that location search results cell right in there. And let's go ahead and see how this looks. All right, so that's looking okay, right? We got to adjust some spacing right here. So on this VStack, let's see. Let me open up my code really quickly. So let's see, on this header right here, let's give that a padding of .top, 64. And that's just going to move that down for us a bunch right there. We're going to put a divider in between these two things and say .padding of .vertical. And that's just going to create some separation between the header and the results. You know, that gives it this nice like separation so the user knows that these are two separate things. And that's starting to really look good. So now what we want to do is actually go over the presentation logic for this, right? So basically what we're going to do is back in our home view, we are going to add some tap gestures to this location, or add a tap gesture to this location search activation view, toggle some Boolean property that we're going to create that determines whether or not we show that view. So first off, let's go ahead and create that property. We're going to say @state private var show location search view, and it equals false. And then we're going to go here and say .on tap gesture perform show location search view .toggle. So now when we tap this thing, this guy's going to change to true. So now what we're going to do is introduce some logic in the view body to say, hey, if show location search view is false, then show the activation view. If it's true, show the location search view. So let's go ahead and just cut this code with Command X. And we're going to say if show location search view and add an exclamation point before it, right? So if we're not showing that, or, you know, we could do it either way, then we can just go here and say location search view. And then else, you can then go ahead and say, or just paste all that code we had in there. Okay, so that looks awesome. Now let's go ahead and just tap on this and see if that works. Okay, so that looks okay, right? It doesn't look like the way we want it to just yet. It is showing our view right here, but we need to change the background color of it because it's completely transparent and that looks stupid. So let's go back to our location search view, and on this VStack, guys, just go ahead and say .background is .white, just like that. And this view is going to look exactly the same, the preview, because it defaults to white. But if we go back to our home view and we let it load, do its thing, now this should look exactly how we expect it to. So let's click on it and boom, that looks absolutely awesome, right? Now we just need to add some logic to this view to make it to make it like exitable, right? Because right now we have no way of getting out of this view and getting back to our main view. That's not good, right? So let's go ahead and do that. So in our location search view, we're going to add a binding variable here as well. Actually, yes. No, sorry guys. We're going to add that in our MapView action button, because the logic is that we want to be able to click on this and then have our button change its state. And then when we click that button, that's what's going to take us out of that location search view. And later on, we'll be able to click on one of these guys, one of those locations, and that's what the functionality is going to look like, right? It's going to show us this like request ride view, and then it's going to draw a polyline to our location and give us like an estimated time of how long the trip is going to take. So let's just go back to this MapView action button, and we're going to add a binding property here. We're going to say at binding var show location search view, and it's going to be a Boolean. And the first error we're going to get is in our preview. We need to provide our preview with a value. And basically we're saying that, hey, this is a binding property, and that needs to, every time we initialize this view, we have to pass in some binding Boolean property that determines whether or not we're going to be showing that location search view. So go ahead and hit fix down in the preview and just say .constant, and you can just say true or false. It doesn't really matter. The next error is going to be in our actual home view, and that's because we're creating this MapView action button and we need to pass it that binding property. So go ahead and say $show location search view. Okay, so this is where some magic happens, right? So like we have the state property here, and we have this logic, this presentation logic here on which view to show based on this state property, right? So when this property changes its value, our view reconfigures or redraws itself and reconfigures itself with the updated state, right? So if we change this to true, the view says, hey, you changed the state property. Now I need to go back through this logic, and it says, okay, now this is true, so I'm going to show the location search view. So now we've added that as a binding property to our MapView action button, so that when that property changes in the MapView action button class, it's going to change here as well, because those properties are bound together. That's what binding means. So back in my MapView button, we're going to implement this simple line of code that's going to make all this magic happen for us. We're going to say show location search view.toggle. Right. So once again, guys, once we change this property, because it's bound to the home view state property right here, once we change it in the map view class, it's going to change here as well. The view will reconfigure itself with the updated state and take us back to normal. So let's see. Let's go ahead and wait for our preview to load. Awesome. So we do that. We hit that and boom, check that out. That is absolutely amazing. So we have a way to activate our location search view, and we have a way to deactivate it and go back to our map view. So that's absolutely incredible, guys. What I want us to do next is just add some animations before we end this module. So that's really simple. We just need to cut in this tap gesture in the home view. Just highlight this and cut it out and say with animation dot spring brackets, and then place that line of code back in there. And then we're just going to copy this, go back to our map view action button, and do the same exact thing. And now let's actually run our code so we can see this happening live in the simulator. And sometimes the animations are just a little cleaner when you run things in the simulator as opposed to running them in the preview. So let's just go ahead and wait for this guy to build and see if we did all of this right and see it happening live in the simulator. All right, so our user interface looks great. We notice that we're zooming in on our user's location. We can move the map around and all that good stuff. So here Ooh, okay, so that's something we have to fix as well. We don't want this to toggle our search view, right? So we're going to fix that in another video, but the main piece of functionality here is we get that nice spring animation there. And then if we hit this button, we get that nice spring animation of it going back to our map view and bringing this back into view. The last piece of this module that I want to implement is actually changing the image of that button to be that like back arrow once we're in the location search view. So let's see. Yes, here we just need to implement some logic for this image name. So just go ahead and highlight that, guys, and cut it with Command X, and we're going to say show location search view. Yes, and it's going to be arrow.left. No. And then paste in line.3.horizontal. So this means that, hey, when we're showing the location search view, it's going to be a left arrow image. And when we're not, it's just going to be that hamburger menu image, this guy we see right here. So once again, let's go ahead and run that. And we are going to see if this works. And it should have that nice spring animation for us as well. So I'm going to hit this. And you guys notice that that looks absolutely beautiful, right? Boom, boom. We can go between these two views seamlessly now. So our app is really starting to come to life. We got some cool functionality in here, some awesome user interface components. It looks great. Our code's clean. This course is going great. I hope you guys are enjoying it. In this module, guys, we are going to implement the functionality of our local search completer. So what exactly do I mean by that? So this really awesome piece of functionality is that if I go into this search bar and I start typing something like coffee, I'll get a bunch of coffee shops that show up nearby. So you can search for generic words as well as addresses. So for example, if I delete all that and I just typing in 123 Main Street, you guys will see a bunch of 123 Main Streets show up, and they're all local to where I'm searching. So in the simulator right now, my location is in California. That's why all of these results are coming up in California. You can also just search for any address in anywhere in the nation. It just prioritizes local results first, and these results update in real time. So this is a really awesome feature, and luckily Apple provides us with a framework for introducing this awesome functionality. So let's go ahead and go over how we're going to do that now. So we are going to be getting started by creating a view model in our location search folder. So we're going to hit Command N here on our view model folder, and we're just going to create a Swift file, and we're going to call it location search view model. So we need to import a couple things. We're going to import MapKit, and that should be good for now, I believe. We're just going to create a class called location search view model, and it's going to conform to the NS object protocol and the observable object type alias. And I'll go over why we have to make this an observable object in just a little bit. Let's go ahead and create some marks in our code just to organize our file. And we're going to create this published property, and it's going to be called results equals an array of MK local search completions. So you guys will see here in the documentation that this is a fully formed string that completes a partial string. So that's what we were seeing here, right? If I start typing in 1, 2, 3, like back in my completed app, if I type 1, 2, 3, it automatically completes the search results for me with the things that are closest by or most relevant to what I'm typing in. So let's go back and just say MK local search completion and initialize that as a blank array. We're going to go here and say init and just hit enter. This has to be an override initializer because we do have to conform to the NS object protocol in order to get this local search completion functionality. So we need to create some other properties here as well. So I'm going to go ahead and create another property, say private let search completer equal MK local search completer. So this is the actual search completer object that we're going to use in order to search for those locations. And then we need something else called a query fragment. It's going to be a string. It's going to be blank at first. And now we're going to go into our initialization method, and we're going to say search completer dot query fragment equals query fragment. So this query fragment is what the search completer uses to search for all of those locations. So basically we need to go over how to set this query fragment, and we also need to go over how to populate this results array and ultimately display them in our search results list. So another thing we need to say is search completer dot delegate equals self. And this is going to throw an error. And this goes back to this protocol stuff, and I'll do a brief explanation of it. But like I said before, if you guys are totally clueless as to what protocols and delegates are, I'll try to provide a tutorial on YouTube explaining what protocols and delegates are, especially those of you who are pretty new to iOS development and you've only worked with SwiftUI. This is going to be a pretty foreign concept, but like I said, I'll do my best to explain it briefly. So you guys are going to notice we get an error here. You can just go ahead and hit fix. And you notice now that we're conforming to this local search completer delegate right here. I actually like to do this using extensions just to, once again, sort of compartmentalize your code and make it neater. So I'm going to create an extension on location search view model and go ahead and conform to that protocol here. So I believe we can just paste it in. It's called MK local search completer delegate. So once again, if you guys try to build your project, I believe it should succeed now. So if you just hit Command B, your build should, okay, it fails. Oh yeah, we have to say super.init here. So because we are conforming to the NSObject class, we have to initialize it with this super initializer. Don't really worry about that too much. It's just object-oriented programming principles. But anyway, let's go back and talk about this local search completer delegate. So we've seen this concept a couple times now with both the location manager delegate and the MK MapView delegate. So you guys are going to notice we get access to a really useful function here called did update results. So you'll notice it says this is called when the specified search completer updates its array of search completions. So basically, there's some code that happens under the hood. When I say under the hood, it means we don't really see it happening. It's Apple's code, right, that they have written as part of this MK local search completer framework. And basically, once it executes a search based on the query fragment, and then once that search completes, it calls this function, and then now we can get the results back from this function once it gets called under the hood, so to speak. So once again, guys, it takes in the query fragment, it executes some sort of search that goes on under the hood or in the background, and then once those search results are populated, under the hood, it calls this delegate method, and then we get access to it here, and we can do what we need to do with the results from that. So this is going to be super, super simple. All we have to do is say self.searchResults or results equals completer.results. So you guys will see here that the data types match up exactly. This is an array of MK local search completion, and this is an array of MK local search completion. So it's the most recently received search completions. So all of these guys are essentially search completions, right? We gave it some query fragment, and then it did what it does under the hood and searched for a bunch of locations using that query fragment and completed them for us. And then once they're complete, we get access to them through this function right here. So I'm going to create another mark here just to make sure that we know that this is, the section for the local search completer delegate. So now we've pretty much done, one of the two things that we need to do. We're setting this results array right here. The next thing we need to do is go over how to set this query fragment and update it in real time. So every time the user types something into this text field, we want to update this query fragment. So let's go over how to do that. So we're going to go back to our location search view right here. And we need to initialize our view model. So I'm going to say at state object var view model equals location search view model, just like that. And now what we need to do is provide that view model with its query fragment. And so we need to basically link this text field that we have here in our header view, right? This where to text field with that, that view model query fragment property. So really quickly, we're going to replace this destination location text. So say $view model dot query fragment. Okay, so that looks good. Now let's go back to our view model. And we can see here that we're using this query fragment on the view model, and we've now successfully like binded it or bound it, whichever one you want to say, to this text field here. So let's go ahead and add a little bit more code to see how exactly this is going to work. So add a bracket to create a block here and say did set. Now let's just go ahead and say print debug query fragment is query fragment. So basically what this means, guys, is every time we set this query fragment, meaning every time we change this text in this text field, we're going to say, okay, go ahead and print it out just so we can see what it is, right? That's what this did set guy means. It says, hey, anytime this thing gets set, execute the code that goes here. So we're just printing out the query fragment. I just want to do this to see if we're actually getting back what this query fragment is. So let's just go ahead and now run our code. And let's see if this is working correctly. Then the next step is pretty simple. We just have to set the search completer query fragment to whatever this query fragment property is going to be. So let's go here, and I'm going to say 1, 2, 3. And you guys will notice that this looks really cool, right? We're getting this query fragment inside of our view model now. So we type some text here, and every time we change the text in here, so I could delete this guy, it's showing up there as well. So that looks really, really good. The fact that it's showing up twice is kind of irrelevant. That doesn't matter. Now all we need to do is take this query fragment that we have and set it on the search completer so that, hey, it knows that that's the query fragment it's going to use to search for its location. So we're just going to say search completer dot query fragment equals our query fragment. And we can go ahead and delete this line of code here. Okay, that looks great. There's just one more piece of this puzzle to get this to come together full circle. We just have to go into our scroll view now and loop through the view model's results as opposed to just this static range of numbers. So we can say for each view model dot results id \self, and then let's just go here and replace this with result in, and we'll see how we're going to use this result in a little bit. I just want to go ahead and see if we're getting back or if our results are updating in real time. Everything is still going to have that dummy data because we're not actually populating our result cell with any of the result data. But you will be able to see, okay, now this list is blank, and that's because the query fragment is blank. But if I start typing out 1, 2, 3, we notice that it populates, and like we can't really see it populating in real time. So let's actually like change the address. Let's do like one hacker way. Right. So now we only get 3 results, and that's because, you know, the result from this query fragment is only returning 3 results. So we know that we're successfully updating our list now, which is absolutely awesome. The last thing we need to do is actually populate our results cell with some data. So let's go into this results cell, and we're just going to replace these hard-coded values with information that we're getting back from our local search completion. So we're just going to want a title, which is a string, and a subtitle, which is also a string. And we're just going to go ahead here and replace that with title and this with subtitle. It's that easy, guys. So this is going to be our moment of truth. We're going to get some errors. We need to replace or add these parameters to our preview. So we can just go ahead and put some dummy data back in here. We can say Starbucks 123 Main Street. And now back inside of our location search view, we now actually have to populate this result cell with a title and a subtitle. And it's actually super, super simple to get back from this result object. We can just go ahead here and say title, result.title, subtitle, result.subtitle. Right, so luckily for us, this MK local search completion has a title and a subtitle that represents the address of where we're looking at, like pretty much exactly how we set it up here. So if you guys want to see where I got those from, you can just command click into this local search completion guy, and it will take you to like the code documentation for it. So just hold down command, click on that, say jump to definition, and let's go and see what the documentation looks like before we check out check to see if our app is working as expected. So you guys notice here that we have these properties, right? This title and this subtitle. So that's all we need. And that's where I knew how to get those objects from, or those parameters that are part of this object, right? And this is pretty clean and concise code. And, you know, same thing that we have back in our location search view. Super clean, super concise. Code's not messy at all. Straight and to the point, easy to understand. So this is looking absolutely amazing. Let's go ahead and just type out coffee. And you guys can see here that that is showing up absolutely beautifully, right? Mission accomplished. Let's go. And I can do the 123 Main Street thing again. And sorry, let me take a sip of tea. That looks absolutely incredible, guys. So, you know, give yourselves a pat on the back. That's one more piece of functionality knocked out of the way. And this app is really, really starting to come together. The next step in the process is going to be to actually select one of these locations, dismiss this view, and then do some cool stuff on the map view, right? So I'll show you that one more time. If I select one of these locations, it's going to draw a polyline on the map for me, present this ride request view, and then actually drop a pin on my location and do some more really cool stuff like give me an estimated time of arrival. We're going to introduce a bunch of different Uber types, payment method options, and this confirm ride button. So, and then, you know, something else that's really cool is we have our map action button up here as well. So if I click on that, it just recenters my map and brings my map view back to its original state. So that's super, super clean. I hope you guys are excited for that next module. Let's keep going. What's going on, guys? Welcome back. In this module, we're going to be getting started with the implementation of what happens when a user selects a location, right? So I'm going to go over that one more time. We get our location search view up, we select a location, it dismisses that view, and then it does some stuff on our map view. It generates a route and drops a pin on the destination, and then it presents this location ride request view. So we're going to be starting small and working our way up slowly to this like awesome functionality here. And we're going to just start off with going over how to dismiss the location search view when the user selects a location. So let's go ahead and hop back into our location search view here. And some quick code cleanup, guys. You can just delete this destination location text. And that's because we're now using the view model query fragment as the text property for this text field. So we don't need that guy anymore. So next up, we're going to create a binding property. Binding var show location search view is a bool. And the logic is exactly the same as how we implemented this for this button, right? We pass this a binding property, and then we toggle that property in the button so that it can dismiss the view. So let's go ahead and figure out how we're going to actually use this property and set it to false so that it hides the location search view. So we're just going to go down to one. Let's fix this in our preview. So just say fix right there. And you can just say dot constant, like false, it doesn't matter, true or false. And on this location result cell is where we're going to want to implement this functionality, right? So we're going to say dot on tap gesture. And this is on the location result cell, guys. Then you're just going to say show location search view dot toggle. Okay. So once again, how this works is now we're going to have to pass this location search view, this state property here, right? So this state property helps us with our presentation logic for that location search view, whether we're showing it or hiding it. So now, because we have bound this property to the property we just created in our location search view, when we change that to false, it will also change this to false. It will then reconfigure our view to have the updated or correct state. So we just say $ show location search view. So that's pretty awesome functionality there. Let's go ahead and resume our preview and just see if this is working. You guys could also run the app. It's really up to you. But it is going to be helpful to get our preview up and running here. So anyway, let's go ahead here. Let's just say like coffee lovers. And then if I hit that guy right there, you notice that it dismisses the view, and that's working really nicely. So next up, we're going to be going over how to select a location and like store that selected location somewhere. Because ultimately, like I said, we need to be able to get it back to this Uber MapView representable. So once the user selects the location, we got to store it somewhere so we can eventually pass it all the way back to the Uber MapView representable. So we're going to hop back into our location search view model. And I'm going to create another published property here up at the top. So go ahead and say at published var selected location. And for now, it's just going to be an optional string. The reason it's optional, guys, is because once we initialize this location search view model, there is no selected location, right? The user actually has to select something in order to populate this. So we're going to initialize it as a nil string or a nullable string. And then when the user selects something, if they select something, we're going to populate this property. So in order to do that, let's go down here and below the init function, create another section for our helpers. And we're going to create a function here called select location. You're going to say parentheses underscore location, and it's just going to be a string. And the purpose of this function is to actually select a location. So we're going to say self.selected location equals the location that we pass in. So let's go back to our location search view where we have access to this view model and actually select a location or call that function. So we're going to go back to this on tap gesture function right here, and we're just going to say view model dot select location. Select. We're going to call the function, and we're going to just say result.title. For now, it's just going to be a string. We are actually going to convert this into like some actual location data so that we can do what we need to do in our map view. And let's actually go ahead and cut this with Command X and paste it in there before we toggle the this view, or dismiss it rather. Okay, so just to make sure we're actually getting this guy into our view model, let's go back here and add a print statement. After this, I'm going to say print debug selected location is self.selected location. There we go. All right, let's go ahead and run this and see if we're getting this print statement back once we select a location. And then we're going to move on to how to get this all the way back to the Uber MapView representable. Okay, so that's looking good. We go here, say coffee, and get Starbucks coffee. Okay, so we see here that we're actually populating our property here. So we're reading that, and this is coming from this print statement we added in the view model. So that's looking good. We're actually storing the selected location somewhere. Now we have to go through the process of how to get it back to our Uber MapView representable. So this is going to be fun. So back in our Uber MapView representable, what we're going to want to do is we need to introduce like a state object here, right? So very similar to our view model setup that we have in our location search view, right? Where we have the view model as a state object. That pretty much allows us to observe changes that happen on that view model. We need to do the same thing back in the Uber MapView representable. So basically what's going to happen is when we observe a change, and the change we're going to be observing is whenever that selected location property gets populated, it's going to trigger this update UI view function, right? So on initial thought, you could think we could just do this. You could just say at state object var location view model equals location view model. right? This, however, is not going to work. And that's because we are creating a separate instance of this view model here. Location search view model. So let's go over what I mean by that, guys. These are some object-oriented programming principles. So I'm going to, excuse me, give you a brief explanation of that. So we're initializing this view model in the location search view. That's what these constructors mean, right? We're creating an instance of the location search view model and using it or storing it in this view model property, right? So basically, the selected location is only going to exist on that particular instance. So imagine that this is like view model A and the one back in our Uber MapView representable. Because we're initializing it again, this is a completely separate instance. So it's not going to actually know anything about the selected location because it's a separate creation of that view model. So we actually need to create an environment object here. And I'll explain the purpose of an environment object here in just a little bit. We're actually going to hop up to our app file and we're going to create the state object here. So I'm going to say location view model equals location search view model. And I'm going to go down here and say dot environment object location view model. And now this environment object property is going to allow us to utilize this singular instance of our location search view model. So we're not going to have two separate instances. We're going to have a single instance that we can use across multiple places in the app. So that's going to be really, really helpful for us. So I'm going to go back to my location search view and I'm going to replace state object with environment object. And you're actually going to take this equal sign away and put a colon and remove the constructor. So this is saying that, hey, we're utilizing some environment object and we're not initializing this again. It's all going to use this singular instance of it. So now back in our Uber MapView representable, same thing. We don't need to reinitialize this view model. We're going to replace this with @environment object var location view model, remove the constructors, and we just cast it, right? So that's the difference between casting something and initializing something. So now we're going to be able to go to this update UI view function and we're going to say if let selected location equals location view model dot selected location. Let's go ahead and say print debug selected location in MapView is selected location. Okay, so let's go ahead and run our code again and see if we get this print statement indicating to us that, hey, we've successfully passed this information all the way back to our Uber MapView representable, which is where we need it to once again generate those annotations we want on our MapView. So moment of truth, let's see. Oh, and check that out, right? So we notice that first it gets passed to the view model, and then we get access to that location in the map view there as well. So that's absolutely incredible, guys. So before we move on to actually utilizing that selected location in our map view, I want to bring up this diagram that gives you guys a detailed breakdown of how exactly that works, because I know this stuff is confusing, and I think having a visual diagram of how everything works and how things talk to each other is going to be super helpful. I know I'm a visual learner and this kind of stuff helps me, so hopefully it helps you guys as well. So let's go ahead and start this off. So really quickly, guys, here's the key for what these arrows mean, and then here's a breakdown of each individual step. So we're going to start off with our app, and that's where we create the environment object. And let me just go ahead and show you what exactly that is. And that's what we're doing right here. We're creating an environment object, and once again, that allows a single instance of our view model to be used across multiple surfaces in the app. So we're creating that environment object, and that's this location search view model right here. So let's take a look at some of these arrows before we break down the steps. We notice that this is initializing the location search view model, and then we're using that same instance in both of these views. If you didn't use an environment object, it would be as if you had two separate instances of the location search view model, and only one of them would contain the selected location. This one wouldn't know anything about the selected location, right? So that's why we need to use the same instance in both of these surfaces. So the app creates that guide. That's what we have in step 1 right here. So then we notice here's step 2, right? So the location search view selects the location and stores that in location search view model. So if we look at the relationship between this thing here, the location search view is talking to the location search view model. So that's why we have this solid arrow here. And the, let me actually flip that around. The location search view also owns an instance of the location search view model, or that environment object, right? So that's what this arrow is here. Let me show you what that looks like in the code. So if we go back to our location search view, we see here that we own an instance of the view model. It's this environment object. And we also listen for changes on that view model through use of this environment object. So that's why we have this relationship here. So this guy is both talking to the location search view model, and it also owns and observes changes that happen on it. So that's step 2. We select it, and then the location search view model publishes that property, right? So if we go back to our view model, we notice that this is a published property. So published, once again, means that once it gets published, it sends a notification to the views that are listening for changes on it. And that brings us to step 3, right? Our Uber MapView representable is owns and observe that same instance of our location search view model. So that's why we have this here. But we notice that the location search view model talks to our Uber MapView representable. And if we go see what that looks like in the code, that means that, hey, this location search view model is publishing that selected location, and then it triggers that update UI view function, which is why we get this print statement. So let's take a look at step 3. Uber MapView representable contains the location search view model and observes it. That's why we have this relationship here. This thing owns and observes the location search view model. And then when location search view model publishes property, update UI view function is called or triggered in Uber MapView representable, and we now have access to the selected location. So that's what it means here when this thing is talking to the Uber MapView representable. So that's essentially the process of how we get that selected location all the way from our location search view to the Uber MapView representable. Is all routed through this single environment object of our location search view model. And once again, the app creates that. So I hope that sort of diagram gives you guys a much better understanding of what's going on there. And this picture or diagram is going to be available to you in the resources section for this course. So now that we've done that, guys, let's go ahead and move on to what we need to do in order to utilize this selected location in our map view to start generating map annotations. What's going on, guys? Welcome back. In our last module, we went over how to select a location in our location search view and get that all the way back to our Uber MapView representable. In this module, we're going to be going over how to actually use that selected location and start generating data on our map view or adding annotations to our map view. So first thing we need to do is actually convert this selected location into an actual location object. So right now it's just a string. In order for us to generate annotations on our map view, we need some more data that's relevant to the actual location of the place we selected. Mainly, we just need the coordinates of that location, the latitude and the longitude. So let's go over how we're going to do that now. We're going to modify this select location function a tad, and we're going to also add some functionality to generate a location object out of that selected location. So we're going to change this from a string to an MK local search completion. And that's going to generate some errors. Let's actually go ahead and delete these 2 lines of code as well. And we're going to go back to our location search view and fix the parameter we're passing into this function. So we're going to see why we need to make this an MK local search completion in just a little bit. So we're going to go back to location search view. And in our on tap gesture guy, you're just going to delete the dot title here. So we're just going to pass in the result. So we're going to say view model.select location, and it's going to be this result here. So now, back in our location search view model, we are going to write a helper function here to take this location and actually search for it to generate a location object. So you guys might be like, yo, we already searched for this location. Why do we need to do it again? So unfortunately, this MK local search completion doesn't give us any coordinate data about the location. It actually only gives us like the address like string. So we need to take that address string, like the title and the subtitle, and actually search for it using a search request to generate a real location object. So we're going to go here and we're going to say func location search for local search completion, local search, and it's going to be an MK local search completion. And we're also going to have a completion handler, guys. So we're going to say completion at escaping, and it's going to be an MK local search dot completion handler. There we go. I don't know if we need those parentheses. I don't think we do. Yeah. So let's just go ahead and try to build this to make sure we typed all that out right. Oop. Add a space there and hit build again. Unknown attribute at, oh, I spelled escaping wrong. That's why it was not showing up correctly. Okay. So that might look a little confusing right now, but it's going to make sense as to why we need to add this completion handler in just a second. So let's go ahead and start configuring this search request. So we're going to say let search request equal mk local search dot request. Now we need to configure this request with some data. So we're going to say search request dot natural language query equals local search dot title dot appending local search dot subtitle. So basically this search request needs a natural language query, which is basically just going to be the full address that we get back from this local search completion, right? So if we want to search for Pete's Coffee, we're going to give it the title and the subtitle, which gives it the exact address, the zip code, and the country. And this search request is going to use that natural language query to actually search for the object, or give us back a location object. So then I'm going to say let search equal mk local search, and then here we pass in our request, or search request rather. And then I'm going to say search.start. And you guys notice here that this is where that completion handler comes in. So we can just pass this completion in right here. And now we'll be able to go and call this function up at the top. And I'm going to say location search. And then we can pass in our location guy here. And let's actually change this to make it make more sense. We'll say local search. And then tab over to the completion and hit enter on it. And this completion handler is going to give us a response and a potential error. So we're going to say guard let item equal response dot map items dot first else return. And then we're going to say let coordinate equal item dot placemark dot coordinate. And then we can just say print debug location coordinates are the coordinate. So this is essentially just how we get an actual coordinate associated with the selected location that the user has selected. So just to do a quick breakdown, Apple has this framework called an MK local search. Here we configure the search request, and then here is where the actual search gets executed. We say search.start, and it has a completion handler. And guys, that's because this search utilizes some sort of API, and it takes time for it to execute and give you back some results. So when those results come back, it comes back in a callback or completion handler. And here is where we access that callback, right? So it's like, hey, search for this location. And whenever it's done, we get back this response or this error. And we can handle our error as well. We could say if let error equals error, print debug location search failed with error, and just say error dot localized description. And then go ahead and say return there. And the reason we say return is because if we do get an error, we just want this block of code to execute and then we return. We don't want to keep going further with the execution of the function. So once again, this is the completion handler, and we get back a response or an error. Here we handle our error, and then if we get the response back, we get this map item object, and then through that map item object, we can get the coordinates that we need for that location. And then ultimately we should get back the coordinates for that selected location. So let's go ahead and run our code and see if we are successfully executing this stuff. So like I said, we should just get back this print statement with the coordinates. And then what we're going to be able to do is we already have the framework set up for passing all this information to the Uber MapView representable. We're just going to utilize this coordinate now in the MapView so we can generate our annotations. So I'm going to say coffee. Let's select Pete's Coffee. And that happens super, super quick. You guys notice that we get back the latitude and longitude coordinates for our selected location, which is absolutely awesome. So now we can go and make this selected location like an actual CL location coordinate 2D. And we could call this selected location coordinate just to be more specific. And now we can go back to our Uber MapView representable and say, okay, now here we can say selected location coordinate, and we could just call this coordinate. So once again, let's just make sure we're actually getting this inside of our update UI view function. So we should see selected location or selected coordinates in MapView is this coordinate right here. So let's go ahead and run this again, just to make sure that everything is still functioning as expected, and then we'll actually be able to start using these coordinates to generate our MapView annotations. So let's go here, let's search for coffee again, select Pete's Coffee. Okay, we are not getting that back, and I know why. It's because back in our location search view model, we need to actually, set this property. We had deleted the line of code that selects or that populates that property. So now we can say self.selected location coordinate equals coordinate. Now we can run our code again. And guys, this is a really good example of why it's good to utilize print statements and really take your development in this step-by-step approach. So you know exactly where you could potentially go wrong. If we just kept going with this without really testing it out, and we realized something went wrong later down the line, it would take us a lot longer to figure out exactly where it went wrong, which is why I like to use this sort of incremental step-by-step style of development. So coffee, select that, and you guys notice that we get that second print statement back where we have these selected, where we have, the coordinate in our map view showing up now as well. Now we're actually going to be able to use those coordinates to generate our map view annotations. What's going on, guys? Welcome back. So in our last module, we went over how to get the actual location coordinates for our selected location. In this one, we're going to be utilizing that coordinate data to actually start generating some annotations on our map view. So let's go ahead and get started with what we need to do there. We're going to go back down to this map coordinator class, and I'm going to add some marks here really quick just to organize this code, because we're going to add a lot of helper methods now. And these marks really just help to help you figure out where you're at in your code. So properties, mark life cycle, and then this is mark MK map view delegate. And then we have one more that we're going to create, mark helpers. So we're going to be adding a bunch of functions to this helpers section here, and also some stuff to this MK map view delegate to help us generate our polyline and our annotations and stuff like that. But let's get started with this helpers section. So I'm going to create a function here called add and select annotation with coordinate CL location coordinate 2D. So this guy is just going to help us add that MapView annotation. So that's the first step in this process. Like if I click coffee lovers, we're going to be adding and selecting this annotation here to our destination, and then we're going to go over how to get the route to that destination. So let's see. We are going to say, this is actually going to be really simple. Luckily, we're going to say let anno equal mk point annotation, anno dot coordinate equals coordinate, and then we're going to say self.parent.mapView.add annotation, anno, and then we're also going to select it. That's what gives it this, like, it makes it bigger. So you guys notice if I click on it, it'll make it smaller. If I click on it again, it'll make it bigger. We want to have that annotation selection there. So then we're going to say self.parent.mapView.select annotation right there. Anno, and we're going to say animated is true because we want that really cool animation there, right? Where it like selects it and sort of jiggles it a little bit. That's the cool animation we get. And now let's figure out where we're going to call this function, okay? So we're going to go back up to our update UI view function, and this is where we have access to the coordinate. And you guys notice that in order to call this function, we need to pass it a coordinate. So we have all the data that we need. We're just going to go here, and we're now going to say, we can delete that print statement. We can say context.coordinator.add and select annotation with that coordinate right there. So that's super smooth, right? You guys notice that we're utilizing this context object, and that context is how we access our coordinator. And through our coordinator, we have access to that function. So as I said in the beginning of this course, you're really going to start to see how this coordinator communicates with our overall parent view, which is this Uber map view representable. And now this has really come full circle where we can see exactly how the make UI view function works. That's in charge for making our view and representing it in SwiftUI. And then this update UI view function is going to get used when we want to update our UI view. And we have the data that we need in order to do that. But we can see that we need this coordinator to do this kind of stuff, right? Because this is where we need to like do stuff to the map view and access our map view delegate and stuff like that. So we got to do stuff here, and then we can, access all that stuff up here in the Uber map view representable. So anyway, guys, let's just go ahead and test this out and see if it works. So I'm going to run our code, and let's get our simulator up with our current version of the app. And we're just going to go ahead and select the location and see if it adds. Coffee lovers. So we'll select it. And you guys notice that it doesn't change the region of our map view, but if you hold down your option key and sort of zoom out on the map view like that, you guys can see here that the annotation is showing up all the way over there, right? So it is adding our annotation successfully. Let's go ahead and select another one. Just do coffee, and let's do maybe Pete's Coffee. And you guys will notice that it adds another annotation there. So you guys will notice there's a couple things we got to do here. So every time we select a new location currently, like if I select Starbucks, it's going to add an annotation there. If I select this guy, it's going to add an annotation there. And it's sort of keeping all the pre-existing annotations on my map view, which I don't want, right? So you notice we like every time we select a new annotation, we want to remove the previous ones and then add the new one. And then we also want to make sure we adjust the region of our map to show both our user location and the selected annotation. So let's go over how to do that now. So let's hop back down to this add and select annotation guy. And before we add the annotation, we're just going to add a pretty simple line of code. We're just going to say parent.mapView.remove annotations, parent.mapView annotations. So luckily we can access each and every one of the current annotations on our map, and we're just going to go ahead and remove all of them before we add the new one. So let's go ahead and test that out to see if that's working as desired. And then we're going to go over how to adjust the region of our map view as well. So I'm going to go here, say coffee, do Pete's Coffee, and it adds one there. Let's do Starbucks. And you guys notice that it removed my annotation and then added the new one. So then removed it, added the new one. Removed it, added the new one. So that's working beautifully, and that looks really good. So now let's just go over how to adjust the region of our map view to show the annotations, right? So if I select something that's a little farther away, like coffee lovers, you notice that we're gonna want the map view to sort of animate out in order to fit both of those annotations right there, right? Okay, so let's go over how we're gonna do that. Once again, that's pretty easy. We're just gonna say self.mapView, oops, not self.mapView, parent.mapView.show annotations, parent.mapView.annotations, animated is true. And you guys notice that sometimes we say self and sometimes we don't. You don't need to say self, so you can just delete those right there. The only time you need to say self is when you are inside of some sort of block, like a completion handler or something like that. So you can just say parent.mapView. Let's go ahead and run this, and this should be the last piece of the puzzle for our map view annotations. And once we see that this is working correctly, we'll be able to move on to adding our route to the destination. So I'm going to go ahead and let's go to that destination that's farther away, coffee lovers. And you guys notice that it beautifully zooms my map view out to perfectly fit the two annotations on the map view. So let's go ahead and try another one that's like a little bit closer. Pete's Coffee. And you guys notice that it zooms my map view in to fit those two annotations. And it also removed the other one, right? So like if I zoom all the way out to where that one used to be, we can see that it's gone. So let me go ahead and just do another one. You guys notice that it zoomed to fit those two annotations. Let's go ahead and try another one. Boom. So the annotation looks like a little bit sloppy on the simulator, guys. And once again, that's just like simulator bugginess. If you were to do this on your phone, it would look like perfectly smooth. So that's going to wrap it up for this module. That's some pretty cool stuff we just did there. We're now actually adding annotations to our map view using the coordinate data that we get back from our selected location view, and everything is working as expected. This is really starting to come together, and the code is absolutely beautiful. And we're going to keep going into the next module with generating our route to our destination, guys. What's going on, guys? Welcome back. Hope you are doing well. As always, in our last module, we went over how to add and select annotations on our map view, as well as adjusting the region of our map view to display that selected annotation with our user's location. In this module, we're going to be going over how to start adding a route to that destination location. So let's go ahead and hop back into our Uber map view representable structure or struct, and we're going to add some more helper methods here. The first one is going to be called get destination route. So we actually have to get the route from our user's location to the destination, and then we're going to use that route to generate a polyline. So I'm going to say from user location, CL location coordinate 2D, and then we're going to say to destination coordinate, which is a CL location coordinate 2D. And we're going to have another completion handler here. Completion at escaping parentheses MK route. Go outside of that parenthesis and then say arrow void. And let me just adjust these input parameters a little bit here. Cool. Let's see. We should be good there. Let's just go ahead and hit Command B to make sure. Ooh, yeah, I didn't type that out right. It should be just 2, right? So now Command B just to make sure this builds and we got those input parameters typed out successfully. Awesome. Okay, so let's go over what we need to do to generate a route from a source location, which is our user's location, to a destination. And I spelled destination wrong. We can just say destination. We don't need to say coordinate. That just makes it unnecessarily long. So we're going to say let user placemark equal mk placemark, and we're going to say user location. And then we're going to create this request object. We're going to say mk directions dot request, and this is very, very similar to what we did with the location search. So we generate this request object, and then we generate a direction search from a source location to a destination location, and then it's going to generate a route for us. So we're going to say request.source equals user placemark, request.destination. Oh, sorry guys, we actually need to make this a map item. So it has to be an MK map item with a placemark of the user placemark. So that's why we created this user placemark object, and then we're gonna have another MK map item, placemark, MK placemark. Let's see. Oops. Let's just go ahead and create another property for that. We're gonna say let dest placemark equal MK placemark coordinate destination. Just like that. And then we'll go here and say dest placemark. Cool. So now we're going to say let directions. Ooh, got to add a parenthesis there. So we're going to say let directions equal mk directions. And then we're going to pass in this request object that we just created. So it's the same process. We create this request, we configure the request with some data that it needs, and then we create this directions search kind of with that request object. So now we're going to say, or we can call this directions. So we can say directions.calculate, and it's going to have this completion handler. So we're just going to hit enter on that, and we're going to get the same response and potential error. So let's go ahead and handle our error. We're going to say if let error equals error, print debug failed to get directions with error error.localized description, and then we're just going to return. And then if we get our response back, we're going to utilize that response and say guard let routes equal response dot routes dot first else return, and then we're going to say completion route. So we get back a bunch of different potential routes. I'm sure if you guys have ever gotten directions in your Apple Maps app, they give you I think it's 3 potential routes to a location. We're just going to grab the first one because the first one is typically the fastest. So this is how we're going to get our destination route. And now we're going to create another helper function to configure our polyline. So we're going to say func configure polyline. And I believe we are going to need some input parameters for this guy. So let's see. Yeah. With destination coordinate CL location coordinate 2D. And now my goal here is to call this helper function to help me generate this polyline or configure this polyline. So I'm going to go here and say get destination route. So we need from to, and then we're going to get the completion of our route right there. So how do we get the from location? We need to access this user location, and we actually only have that inside of this function right here. So we have access to our user location here. So what I'm going to do is create a class level property. I'm going to say var user location coordinate is a CL location coordinate 2D. And then we can just go here in this MK MapView delegate function, and let's actually make this optional. And we're going to say self dot user location coordinate equals user location dot coordinate. So now what this helps us do is it gives us access to this on a class level so that we can use that user location inside of these functions here. So now I'm going to go back to this function, and I'm going to say guard let user location coordinate equal self.user location coordinate else return. And now I can pass it in here. So I'm going to say user location coordinate. Let's hit enter there. And then we're going to say this is the destination coordinate to that coordinate, and then hit enter again, and then just hit enter on that completion guy, and we're going to get access to the route inside of this completion block now. And once again, guys, this has to happen inside of a completion block because this directions request is an API. So under the hood, so to speak, in the background, Apple executes some sort of search to generate directions to this location, and that the information comes back to us in the form of this API callback, where we get access to the response and the error. So that's why we have to work with these completion blocks here. So anyway, let's keep going. We're going to say self.parent.mapView, and it's actually required to say self now, as I described before, because we're inside of a completion block. So self.parent.mapView.add overlay route, and you can see we get access to our polyline from this route object, right? So that's how we're going to get the actual like directions route to our destination location. And now we're going to say self.parent. Let's see. Yeah, this should actually be good for now. We do, however, need to go up to our MK MapView delegate and add another function so that we can generate this polyline. So really quickly, in order to show you guys why we need this function we're about to create, let's just go ahead. Oh, we have to call this function. So let's see. Configure polyline with destination coordinate. Okay, so let's go up here, and we can also go into this if let block and say context.coordinator configure polyline with that same coordinate. So we're going to add and select the annotation, and then we're going to add this function to configure our polyline as well. So now let's run this and see what this looks like so far. You're going to notice that a polyline doesn't actually show up because, like I said, there's something we need to add that's part of our MK MapView delegate to help us generate that polyline and display it on the map view. So I'm going to search for coffee lovers, and you guys will notice that like it's just doing exactly what it was doing before. So there's nothing actually being generated yet. So let's go back to this MK MapView delegate guy, and we're going to say renderer for overlay. So this asks the delegate for a renderer object to use when drawing the specified overlay. So this is essentially a delegate method that we need to use to tell our map view to draw the overlay with the selected route that we have. So it's going to recognize that, hey, you tried to add an overlay to the map, and this is the route and the polyline. So now it's going to say, now it's going to use this function to actually draw that out. So we're going to say let overlay equal MK polyline renderer. Let's see, what's the option? Yeah, overlay. So let's just call this like over, because we don't want to duplicate the function naming. So this is the overlay. And now we're going to say over.stroke color equals .system blue. You guys can make it whatever color you want. Over.line width equals 6. And then we're going to return that over. You could call this polyline if you want to make it a little bit more, make more sense, and just paste that in all those places. Cool. So that's looking good. And now if we go ahead and run our project, we should notice that it actually generates the overlay to, or the polyline to, that destination location. So let's see if that works. coffee lovers. And yes, that is looking absolutely amazing, guys. So we have our route to our destination. And let's just go over a quick breakdown of how exactly we got that to work before we end this module. If you're comfortable with that, then feel free to go ahead and move on to the next module. There's a couple other things we got to do to clean this up, but I'm just going to go through a quick breakdown of that. So we had this helper function to get our destination route. And then we have this helper function, which actually configures the polyline. So I broke these up into two things because one, it keeps our code cleaner. Two, we are going to want to be able to reuse this destination route function in the future of this app when we want to be able to generate multiple routes from different places, right? So it's best to have this extracted as a helper function. And like I said, it also keeps the code cleaner. And then here's where we actually configure the polyline using this get destination route function. So we get our user location, and then we say get destination route from the user location to our destination coordinate. It gives us back a route, and then we just add that overlay to our map view. We do have to take this a step further. It's not as simple as adding an annotation, unfortunately. We don't really need to do any MK MapView delegate stuff for the annotation. We can just simply add that, which is nice. But for the overlays, we have to use this delegate function to tell the map view how to draw the polyline and then configure some properties on the polyline with like this color and the line width. You guys could mess around with these and really just customize it to your liking. But that's how we're going to add a polyline to our destination. That's looking really good, guys. But let's take a look at some stuff we need to clean up. So for example, if I selected another location like Pete's Coffee, you guys would notice that it doesn't remove the previous polyline. So I could zoom out and the annotation is gone, which is good, but we want to remove that polyline there as well. So we're going to be cleaning this up a little bit more in the next video. And before we get on to actually like building the UI for this ride request view and all of this cool stuff. So we'll see you guys there. What's going on, guys? Welcome back. Hope you are well. In our last module, we went over how to generate a polyline or a route to our destination. In this one, we're going to be cleaning up this map view a little bit. You can see here that if we select a new location, it doesn't remove the previous polyline and it goes ahead and adds the new one. So we want to clean this up a little bit. And then we're also going to want to give the user the ability to sort of exit out of this this view right here. So you guys will notice that before we get started with this, we're going to be adding some functionality to our map view action button so that if I have a route generated, I can just hit the back button and it will zoom, it will remove all the annotations on the map view, and then it will also recenter my map on the user's location. Something else to take note of here is the way our user interface functions when we have a location selected. So you guys will notice that if I've selected a location, that where to or that location search activation view disappears. And that makes sense from a user experience perspective, right? Because if we've selected a location, we don't really need to have the option to say, where do we want to go? Because we've already decided where we want to go. And then we'll be able to just use this button to exit out of that map state and go and sort of reset our map view. So you guys will notice that our map view is starting to get more complex and it has a bunch of different potential states, right? So we're actually going to create an enumeration here to help us manage that map state and update our user interface and perform certain pieces of functionality based on what the map state is. So let's go to our model folder really quickly. And we're going to create an enumeration for this. So I'm going to say it's a Swift file, and I'm going to call it MapView state. And the benefit of using an enumeration here, guys, over the alternative, which is just using a bunch of different Boolean properties, is pretty significant. And we'll go over why in just a second. Let's just go ahead and create an enum called MapView state. And we'll say case like no input, case location selected. And right now it's only 2 states, but as we start to introduce more functionality into this app, this map view is going to have a bunch of potential different states. So creating an enum really helps you keep scalability in mind and makes your code a lot easier to work with, maintain, and scale. So now let's go back to our home view and let's see if we can introduce this map state. So I'm going to create a state var, private var map state equals map view state. And we're just going to default it to no input. So now we'll be able to utilize this map state to help us with some of our presentation logic here. So we're pretty much going to be removing this show location search view. And once again, if you guys wanted to, just do this in a different way, you would have to add a bunch of different Boolean properties to keep track of your state. And the reason that's not really feasible or ideal is because managing all of those different Boolean properties gets really, really frustrating. You can imagine if you had like 6 different Boolean properties and you wanted to change one to true, you have to change the other 5 to false, and so on and so forth, right? So the map view state gives us a much better alternative to that. So basically, guys, what I'm going to say is instead of if show location search view, I'm going to say if map state equals dot no input. So only if our map state is in the no input state are we going to show this location search view. And we can go here and say else if map state. And we're actually going to go back and add another one. I forgot one. We're going to say case searching for location. So now we have 3 potential states, right? It could be in this no input state. If we click on it, it's going to be searching for location. And then if we select a location, it's going to be location selected. So these are 3 potential states that we have right now. So I'm going to go back here and say else if map state equals dot location selected, or sorry, searching for location. And that looks pretty good. Now let's go ahead and clean this up. So we don't need this state var anymore. And this is going to cause some errors in our project. So we can actually now, instead of passing in this guy, we can pass in this map state. So I'm going to go back to my location search view and I'm going to create a binding variable, map state, which is my map view state. And we're just going to delete this. And that's going to cause some errors as well. Let's just get through this refactor really quick, guys. We're going to say this is a map state, and we're going to say dot constant, and we can just say like dot searching for location. So you can see how much more convenient this enum is, especially as we start to get a bunch of different states in our project. So now instead of saying show location search view dot toggle, we're just going to say map state equals dot location selected. Okay. So if we select a location, we've now transitioned our map state into the location selected state. And then we can go back to our map view action button, and we're going to do the same thing. We're going to create a binding bar for our map state. And then we're going to say is a map view state. And we're just going to replace this with map state, and constant can be dot, let's see, no input. And here, now what we can do is actually create a function that helps us figure out what the action of this is going to be, of this button, because it's going to have a bunch of different potential actions, right? Like for example, if I select it when if I click on this button when my location is selected, and I do that, we're going to want to add some functionality to clear the map view and recenter it. As opposed to if I click on it when I'm here, we want the functionality to just take us back to the default map state, right? So here, I can go here and I can say func action for state, which is a map view state. And we can actually just do a switch on our map view statement, or our state rather. So I'm going to say case.no input, and we can say, print no input. And let's add a debug in front of that. And then for my case of dot searching for location, we're going to change our map view state back to no input, right? So if we're searching a location and we hit this button, we're going to say map state equals dot no input. And then we're going to say case dot location selected. We're going to print clear map view. Right, so once again, we can see the power of this enumeration, right? We can switch through the potential states and then perform some sort of action for that. So here I can now just go and say action for state, and I can pass my map state in there. So now when I hit this button, it's going to update my map state accordingly. And this is way, way cleaner than just using a bunch of different Boolean properties. And let's go here, guys, and we'll say, let's create another function. We'll say func image name for state, map view state. And here we're just going to replace all this code in just a second because we need to adjust the image now based on this map state, right? So I'm going to just copy this switch statement, and this actually has to return something. So it's going to return a string. For no input, we're going to just say return line.3.horizontal. And then for searching for location and location selected, so I can actually just delete this and get this so that it looks like this. Just say comma. So for these two different states, we just want it to be that back arrow. So we're going to say return arrow dot left. Oops, just like that. So now we can go ahead and replace this with the much cleaner function we just created and say image name for state, map state. Cool. So this is super, super clean, and you can see the power of this enum right now. It's helping us compute our image name, and it's helping us figure out the exact action that we want to perform when our map view is in a certain state, right? So this is super awesome, super clean code. And like I said, it gets much more easy to maintain as opposed to adding multiple Boolean variables. So let's just go ahead and build our project. I'm sure we're going to have some errors somewhere. Let's go ahead and fix them. And we're going to see ultimately how this helps us clear our map view out. So this is a pretty awesome refactor. Okay, so location search view. So let's see. We want to remove, okay, so now it's our map state. So we're going to say map state. Map state, just like that. And here, this is where we're going to toggle our map state to searching for location. So I'm going to say map state equals dot searching for location, right? Because when we click the search activation view, we want our map state to transition into this searching for location state. It's going to update this state property, and it's going to go through this presentation logic in exactly the same way and say, okay, hey, if the map state is searching for location, then I want you to show me the search activation view. So if it's location input, oh no, we need to move this around a little bit. So we need to say if map view equals dot searching for location, else if map state equals no input. So let's do this one more time. If map state is searching for location, we show the location search view. Else if map state is no input, we show the activation view. So let's go ahead and try to build our project or run our project one more time. And here we have another error. So we're going to say map state, and it's going to be this binding map state property. And we can just delete that guy right there. So this is looking really good. Let's go ahead and run our project and see if it's functioning the exact same way it was before. And then we're actually going to go back to our Uber map view representable and utilize this map state as well. So if I click on this, cool. Yep, that's working exactly as we expect it to. Here, if I click on this, we're just saying no input. And once again, guys, in the completed version of the application, we have this awesome side menu, but we're not going to be doing that in this YouTube course. That is going to be available in the completed source code, which is available on my website at stephancodes.com. I'll provide you guys with the link in the description to this video. we don't really have time to get through that in this YouTube video. But let's see what happens when we search for a location. So I'm going to select Pete's Coffee, and you guys notice that it draws my polyline to my destination, and that looks great. And it also removes that where to view, right? And now if I hit this, it's going to say, hey, this is where we're supposed to clear the map view. So that's looking really good. Now let's go over what we have to do to introduce this map state into our Uber MapView representable class in order for us to utilize this map state and like actually clear the map view when the user presses this guy. So in order for us to monitor what's happening with this map state in our Uber MapView representable, we're going to hop back over to that class, and we are going to create a binding property here. So I'm going to say at binding var map state is a map view state. And then this is going to require that we actually pass this map state into our Uber MapView representable, and then we'll be able to use it here as well. So let's go back to our home view, and we're going to say map state, and it's going to be this map state right there. And let's just go add some print statements back here to see if this is actually getting read successfully. So every time we update our UI view, I'm just going to say print debug map state is map state. So this will just tell us if we're, successfully recognizing the changes in the map state, and then we'll be able to utilize that map state to go through some logic here to help us do what we need to do. So we see here that it started off as no input, and now it's searching for a location, and then it goes back to no input. And then if I search for a location and select it, Pete's Coffee, we see that it says it's location selected. So that's working absolutely beautifully. Now all we need to do is switch through this map state and use it to help us figure out what we need to do. So before we do that, I want us to write a function in our Uber MapView representable class to clear our map view, because that was the original goal before we did this refactor, right? This refactor is really just going to help us with the further development that we need to do on this map view. Now we're actually going to go back to what we originally intended and go over how to clear that map view. So before we get started with working with the map state, we're just going to write a helper function down here all the way at the bottom to clear our map view. So I'm going to say func clear map view. And we're going to want to remove all of the overlays and all of the annotations, and then recenter the map as well. So I'm going to say parent.mapView.remove annotations, parent.mapView.annotations, parent.mapView.remove overlays, parent.mapView.overlays. So this is going to remove the annotation. This guy is going to remove the polyline or the overlay we have. And then the last piece of the puzzle here is we need to recenter the map. So we're going to need to create a class level property for the current map view region. So I'm going to just say var current region, which is a MK coordinate region, and it's going to be optional. And we're going to update this property down here the same way we update the user location coordinate. So currently the user location, this region is based on the user's location. So we're going to go right below that and say self dot current region equals region. And this will also do us the favor of every time the user updates their location, it's going to update the current region in the map view as well. So then we set the map region, and that's the initial state of our app, right? It centers on the user's location. So then we're going to go here and say if let current region equals current region, we're going to say parent.mapView.set region current region animated is true. So let's actually call this clear map view and recenter on user location. So now we'll be able to go back up to this map state guy. We can keep this logic the same for now. We're just going to go below this, and we're going to say if map state equals dot location selected, And then we are just going to say context.coordinator.clear map view. Or sorry, no input, my bad. Clear map view and recenter on user location. So let's go ahead and run this, guys, and see if it works. Ooh, so wait, hold on. Yeah, we need to go back to our map view action button and actually reset our map state, right? So if we were to, let's just run through this right now. So I'm going to say coffee, Pete's coffee. It's going to generate my polyline, add my annotation. Right now, it's just saying clear map view, right? So here, we're just going to adjust our map state back to no input. And then back in our Uber map view representable class, it's going to say, okay, hey, we updated the UI view and the map state is now no input. So then we're just going to go ahead and clear the map view and recenter on the user location. So let's go ahead and do that now. So let's see, location, map view action button. There you are. We're going to say map state equals dot no input. So now let's go ahead and see if this works. And I believe this might have some issues, but let's see if it works. So we're searching for our location, coffee, Pete's coffee. That looks great. And now let's hit this. Oh, and check that out. That looks great. However, we do realize that it doesn't clear our overlay. It does clear our annotation and recenter on our map view. So that's great. Let's go ahead and figure out what we need to do to actually clear that overlay out as well. So let's hop back into our Uber map view representable, and we're going to change the logic here a little bit. So let's actually do a switch on our map state. We're going to say switch map state. And let's go through all of these guys here. So basically, if it's no input, we want to say, we want to do this. We want to say context.coordinator.clear. If it's searching for location, we'll just break. And then after this, say break as well. And then if it's location selected, we are going to then paste this code in here. And let's just go ahead and comment this out. And let's see if this works now. So if it's no input, it's going to clear everything out. If it's a location selected state, then it's going to do that, right? So I believe we were just mixing up the states. So because that location was still selected, it was still generating that polyline. So let's see if that's working now. Coffee lovers, cool. And boom, that is absolutely beautiful, guys. So let me just go ahead and give you a breakdown of why this wasn't working before. So we had this logic up here, right? So, and then let me just comment out this switch statement. This was the configuration beforehand. So, and let me comment this back in to make this clear. And I'm just going to cut this and paste it back in later. So basically, we were changing the map state back to no input, and it was calling this update UI view function. But we never set this selected location coordinate guide to nil, right? So you have to do that so that this doesn't run. So it was then redrawing the polyline, and then it was going to the context.coordinator and clearing the map view and recentering on the user location. So that's not how we want to do this. We want to introduce this switch statement. And let me comment this back in and indent it. So now it's only, if the map state's in no input, then it's just going to do this and it's going to break. If you don't have this break statement there, it could cause things to, keep sort of falling through this switch statement. I think it would be fine actually, but just make sure you add those break statements there as well. Let's go ahead and add one here too. So now when the map view state changes back to no input, it clears everything out and it never even hits this guy. Because before we didn't have this logic dependent on the map state being .location selected. So let's just run this one more time just to make sure everything is working. And then I'm going to give another brief rundown of how this map state has helped us out tremendously with the complex sort of view logic that we have going on. So right now you see map state is no input. That looks good, right? So this function is going to get called, or this print statement is going to get called every time this update UI view function gets executed. So now it recognizes that we're searching for a location. And if I were to exit out of that, hey, it goes back to no input, right? Boom, boom, perfect. So now I'm going to go ahead and search for a location, Pete's Coffee. And then now, okay, check this out. It says map state is location selected. So it skipped through both of these states. It hit this guy and said, hey, we have a location selected. Now we're going to go through this logic and add and select the annotation and configure our polyline. And now if I go hit this guy again, it says map state is no input. And then it gives us back our location search activation view and removes all of the annotations from our map. So that's absolutely incredible. So if you guys are comfortable with how that works, feel free to hop over to the next module. And if not, I'm just going to give a brief rundown of everything we just did, because we did some refactoring and we also use that refactor to help us get this functionality working in our map. So we created this map state and it's an enum. And once again, this is the purpose of this is because our map is going to get really complex moving forward with all the different potential states that we have. So it's better to utilize an enum to do that. And another thing this helps you with is scalability, right? So if I add a case to this, everywhere that I'm using this logic and I have the switch statements implemented, it's going to make me add or remove the cases that I add to this enum. For example, if I have a case for like ride requested or something, and I try to build my project, it's going to say, hey, you are not using all of the switch statements you need to. So we would need to update like our image name for our map state, the action for our map state with this newly added state that we have and all that stuff. So this is much more scalable, a much more scalable solution than using a bunch of Boolean variables. So where are we utilizing this map state? Well, it's back in our home view. So we removed that Boolean property of just showing or hiding the location search view, right? That was back when our map view was a little bit more simple and we only had 2 potential states. Now we have multiple potential states, so we want to transition into using an enumeration. So we pretty much just replaced the Boolean logic with our map state logic, right? So if map state is searching for location, we show this location search view. If it's no input, then we show the location search activation view. And when we click on that guy, then we change it to searching for location. This is a state property, so it reconfigures or redraws the view with the updated state and shows me the stuff I need to see. We also use that in our MapView action button. And we can see here that we have different actions for our map state and we have different image names for our map state on this button as well. So this is super smooth implementation here where we're utilizing this map state in multiple places to help us figure out all of the complex logic that's going on in our app right now. And then lastly, we use it in the Uber MapView representable. And this is arguably where it's the most helpful because updating our view gets pretty complicated, with all the stuff we have to do on the map and clearing out the map and showing different views and all that stuff. So this map state really helps us out there. And once again, we get to use this really helpful switch statement to help us manage all of the different potential states in our map state or our app. And like I said before, as this map starts to get even more complex, this map state is really, really going to come in handy. So that's a beautiful refactor there, guys. And we have the app working exactly as expected. Next up, we're going to be building out this awesome ride request view, and we're going to be populating it with all of the data that we need, different Uber types, payment types, and all of that good stuff. And then we're also going to be adjusting our map view even further so that it fits the, we get the correct map region with this view showing on top of our map. So get excited for that, guys. We'll see you in the next module. Peace. What's going on, guys? Welcome back. In this module, we're going to be getting the user interface for our request ride view built out. So let's go ahead and jump right into it. So I'm going to close some of these folders out and we're going to create a new one in the core folder, and it's just going to be called trips. And then I'm going to create a new file there, and it's going to be called ride request view. just like that. And I'm going to keep this up so we can reference it as we build the UI. If you guys want to go ahead, pause the video and see if you can build it out yourself. That would be a fun little exercise. If not, I'm just going to go ahead and get started with it now. So this is going to be a VStack. And we're going to create this capsule first. That's going to be super simple. We're just going to say capsule dot foreground color is color dot system gray 5. Then we're going to say dot frame is width and height, of 48 by 6. Then I'm going to create an outline for us really quick. We're going to have our trip info view right here. Then we're going to have this ride type selection view next. Then we're going to have our payment option view. And then we're going to have our request ride button. So that's just a quick outline for us there. Let's go ahead and get started with this trip request or info view right here. So you guys should remember that we have this set up already. So we're going to go ahead and build that out now. And we can just copy and paste it really from our, what's it called? Location search view. Yeah, right here. So let's just create or grab this code right here. Grab the H stack and the V stack. So let's see, back to trips. And we're going to go here, stick that guy in there. And then we need to add another bracket. So just make sure all your brackets close correctly. And we're just going to change the dimensions of these to make them a little bit bigger. Width of 1, height of 32. And this guy's 8 by 8. And then this guy's going to be 8 by 8 as well. And let's just go ahead and resume our preview, guys, to make sure that this looks good and is building successfully. And if you guys want, as an exercise, you could try to refactor this into a single class and just, pass in maybe some different, like a Boolean property for like a large and a small config. But I'm going to leave it as is. It's some pretty simple code. And like I said, if you guys want to refactor that, use that as a little homework assignment. Preview might take a while to build, so I'm just going to keep going. Oh, there it is. Okay, so there's our capsule, and then there's this guy we have here. And this is an H stack, so let me just go ahead and fold this V stack. Oops, wrong. Command click on that bracket and then select fold. And then we're going to go here, and then we're going to create these items here now. So this is going to be another V stack. And we're going to say H stack within that. And we're going to have a text for our current location. And this is going to be .font .system size of 16. .foreground color is .gray. So that's how that looks as of now. And then we're going to add a spacer in this H stack. And we're going to say text, just like 1:30 p.m. .font. And we can say .system size of 14. Weight .semi-bold. And then we are going to give it a foreground color of .gray. Cool. And then we are going to give this guy, this H stack right here, a bottom padding of 10. So that's just going to line it up a little bit better. We're going to build another one of these really quick. So just go ahead and copy and paste it. And this is going to say like, Starbucks coffee or something. This is our destination view. And then let's see, let's make this like 1:45 p.m. And then that should be good. Now we just need to make sure we line that up correctly. So let's see, I think we need to add some spacing to our VStack. So I'm going to say alignment is .leading. Spacing is like 24. And let's see how that looks. Okay, so that looks pretty good. Let's remove this bottom padding on the destination H stack. And then I'm going to do just like a quick overview of how exactly that works. Right, so that lines up perfectly, you guys can see. So then on this big H stack, that's the parent H stack of our trip info view, we're going to say dot padding. And let's see how that looks in just a second. Okay, so this looks much, much nicer. And one more thing that we're going to do, guys, is give each one of these text components some more spacing from this little like indicator view. And we need to change the color of this Starbucks coffee guy. So we're actually just going to delete that gray foreground color. So it's going to be black. Just like that. That looks good. And we also want to give this a weight of semi-bold. So go ahead and say weight.semi-bold. And also give the current location a weight of .semi-bold. Okay, so that should load in just a second, and now that's looking much nicer. Now, like I said, we just want to give this each one of these H stacks some leading padding, or we could place it on this entire V stack really. So then here, go ahead and say .padding. .leading and give it like 8 pixels or something. And that should just move those text components over by just a little bit. So let's break this UI down really quick. So this right here was our indicator view. And then this V stack here is everything that we see that's not this indicator view. So it's these two H stacks really. So that's just how I chose to set that up. You might think about it a little differently, but this works just fine. So this is a vertical stack that contains two H stacks, which is what we see here. So it's this V stack with two of these H stacks that contain some info about our trip. So that looks good. Now we're just going to place a divider here. And we should see that coming up. Let me zoom in on this guy. Yeah, that looks a lot better. Okay, cool. So let's keep going. We're going to create this text for our suggested rides. Then we're going to say .font. Let me move this below our comment to make sure we stick to our outline. And then our font is going to be .subheadline. And let's see how that looks in just a second. Cool. Then we're going to say .font weight, .semi-bold, .padding, .leading. Then we're also going to give it a padding on the vertical edges. You know what? We could probably just say .padding. And we'll see how that looks. And then we are going to say .foreground color, we can just say .gray. So let's see how that looks. Cool. And then we want this to be on the leading edge, right? So we're going to say .frame, .max width, not .max width, just max width. Infinity alignment is .leading. So that's going to align it to the leading edge for us, and it should have some padding. So that looks great. Next up, we're going to create this scrollable view of each one of our ride options. And in a different video, we're going to go over how to select a ride option. So we are going to go down here and create a scroll view. We're going to say .horizontal because it's a horizontally scrollable list. And we're going to say HStack, and it's going to have a spacing of 12 pixels. And we're going to then say for each 0 up to 3. And we're actually going to configure like a ride type structure. To do this for now, this is all just going to be dummy data. So I'm going to say ID \self bracket underscore in. And now I'm going to create each one of these ride item views. So really quickly, guys, this is going to be a VStack with alignment of .leading. And our content is going to be as follows. It's going to be an image with a system name of Uber-X. And you guys are going to be able to download the resources for this. There's going to be a link in the description to this video. So just go ahead and make sure you grab this image, and that's going to give us that awesome like Uber-X looking image right there. And then we are just going to say .resizable .scaled to fit. So actually go ahead and delete that system name. It's just going to be Uber-X. And once again, make sure you guys download those assets, and you should have them looking like this in your project, Uber-X and Uber-Black. So back to our ride request view. Right now, this image is going to be massive. So we're actually going to go ahead and give this VStack a frame, and it's just going to scale itself to fit that frame. So we're going to say .frame width of 112, height of 140, .background color .system grouped background .corner radius of 10. So that looks pretty good. Now we're just going to create a text component and say Uber-X. And then we want to give it pretty much the same font as this text guy up here. So you can just go ahead and copy and paste this guy that says font system size 14, weight semi-bold. And we're going to go ahead and paste that in there. And then just copy this and make this say like, I don't know, $22.04 or some price. Okay, so that looks okay. I think what I want to do is actually wrap this inside of its own VStack so we can apply some custom spacing and stuff to that. So let's see how that looks. Okay, and then we can say like spacing of like 4 pixels. So that'll just give it some spacing there. Yeah, that looks better. And then we'll give it some padding on the vertical and leading edges. So we'll say we could just say padding and give it like 8 pixels of padding. And we'll see how that looks. Cool. So that looks great. Our car looks great. It's scaling to fit our, our stack here, or the size of each one of our items. Now, on this whole VStack, we're going to want to apply some padding on the leading edge as well. Or we could do that on the whole scroll view, actually. So we can just go on the scroll view and say padding.horizontal, because we want it on both the leading and trailing edges. So let's see how that looks in just a second. Perfect, right? So that's that nice scrollable list. So the reason we made it scrollable, guys, is because this might not fit the width of all phone screen sizes. And also if you want to add other ride options like Uber Comfort or Uber Pool or whatever, this just makes it so that it's more scalable and you can scroll to select whatever option you want. So that looks great. Now let's go and create this payment guy and then our button right here. Let me just go ahead and fold this scroll view so we have some more room to work with. Perfect. So now we can see this is next in line. Payment option view. So this is going to be an HStack, and we're going to give it a spacing of 12 pixels. And we're going to say text Visa .font .subheadline .font weight .semi-bold. We're going to give it 6 pixels of padding. .background is going to be .blue. And then we're going to say .corner radius of 4. .foreground color of .white. Padding of, I believe we want to say .leading. So that's for our little, Visa card guy. That looks pretty good. Now we are going to just go here and say text star 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 1 2 3 4 dot font weight dot bold. Oops. So we'll see how that looks. And that looks pretty good. Now we're going to give it a spacer, and then we're going to give it this little caret or chevron, I think it's called. So say system name chevron dot right dot image scale is dot medium dot padding. And then we are going to give this guy a frame just of 50 pixels. Dot background is going to be color parentheses dot system grouped background. Dot corner radius of 10. Dot padding of dot horizontal. So that should look pretty good now. Let's just wait for our preview to load. So perfect, that looks awesome. Now we just need to build this confirm ride button. So once again, let me just fold this up. Great, and now we have our request ride button. So this is just gonna be pretty simple. It's a button with this action and label. And we are gonna go here, and this is going to just say text confirm ride dot font weight of dot bold dot frame height of 50. And we're actually going to want to give this guy a width as well, because we don't have it wrapped in an H stack or anything. So I'm just going to say width of UI screen dot main dot bounds dot width minus 32. So this makes it a little like more dynamic in terms of the UI. It's just going to stretch to fill the width of the screen and then give it 16 pixels of padding on each side, right? So that's already looking pretty good. And then we're going to say dot background of dot blue dot corner radius of 10 dot foreground color of dot white. And then I believe, yeah, that should look good. Okay, perfect. So that's pretty much going to wrap it up for this user interface, guys. I actually do want to add a divider between these two things just to give them some separation though. So let's see. In between our scroll view and our payment option view, we're going to add a divider. Great, and we're just going to give that some padding on the vertical edges. So we're going to say vertical of like 8 pixels or something. And that's just going to space it out on the top and bottom. So this just gives this some nice separation, right? It's clear that this is a section, and that this is a section of our view. And then lastly, we just want to give this entire thing, this entire VStack, a background of white. Dot white. Okay, so that's going to wrap it up for the user interface. And really this module, I just wanted to get that built out. It was a little bit strenuous. And in the next one, we're going to go over the presentation logic for this sort of like ride request card. And we're also going to go over how to adjust our map view to fit this frame. What's going on, guys? Welcome back. Hope you are doing well. In our last video, we created the user interface for our ride request view. In this module, we're going to get started by going over the presentation logic for that ride request view. So basically, when the user selects a location, we want to then present the ride request view to them. So let's go ahead and figure out how we're going to do that. So first, let's go over the layout that we have to introduce in order to accomplish this. So we're going to create another Z stack here. So we're basically just going to command click into this Z stack and create another Z stack. So just say embed in Z stack, and the alignment of this one is going to be dot bottom. So this is one Z stack, right? This is our map and the like user interface components for the map. Oops, I spelled alignment wrong. And this Z stack is going to be where we actually present that sort of ride request view. So let's go ahead and just fold this guy up, this first Z stack, the MapView Z stack that we have. So we're going to say fold. And now here we're going to basically just say if map state equals dot location selected, then we're going to present our ride request view. Just like that. So it's pretty simple to accomplish this. The trick here is really embedding it in that second Z stack. So this Z stack is going to stay the same. All of that's going to show up just fine. But with this new Z stack that has an alignment of bottom, we're going to be able to show that card sliding up and have it show up on top of our map view. So that's going to be pretty cool. Really quickly, to get like a nice animation for this to happen, we are going to want to go back to our location search view and go back to this on tap gesture function. And right now there's no animation happening when we change our map state. We're going to want to modify that really quickly. So let's just go ahead and cut these 2 lines of code and say with animation dot spring, and then just paste them back in there. So now we're going to get a nice animation to show our card view and our ride request view. And in order to get this like sort of slide up effect, SwiftUI has a really cool modifier called dot transition. And we're going to say dot move from the bottom edge, just like this. So it's going to have that nice spring animation and it's going to move up from the bottom edge and present itself with this nice like slide up card sort of animation. So let's go ahead and run this really quick and see if we're getting this to work. And I believe it should work straight off the bat, and it's going to be pretty dope. So application runs, that's great. Now, moment of truth, guys, let's go through our app and see if we got this working. We're going to say coffee lovers, and then I'm going to select that option, and boom, that is so cool, right? Our card slides up beautifully. The user interface looks great. There's just a couple things we got to do. Like we're going to want to put some padding on that little capsule there. We aren't going to introduce any sort of like slide down to dismiss. We don't really want that, in my opinion. I think it's better to just use the back arrow here. That's what it's for. You guys are going to notice that we also sort of have a problem with our map view, right? Like, we want to adjust the visible rect of our map view or the visible frame of it when this slide up card like animates up to actually fit the annotations on our map view. And guys, we should have this working where we just click that guy and boom, it dismisses our slide up card perfectly. And it takes us back to or resets our map view configuration and centers it back on that user location. So really quickly, let's go ahead and fix our UI on that booking view or ride request view. And we're going to give this capsule some padding. We're just going to say padding.top and just give it like 8 pixels of padding. And let's go ahead and run this one more time. I believe we're going to want to put a corner radius on this guy too. So like maybe we could go all the way down here. And let's see how it looks first. So coffee, select Pete's Coffee. That looks awesome. So we got that little bit of padding that we want. And we're going to adjust our map view in just a second here. Let's go ahead and see if we can give these some rounded edges. So really quickly, just go and say dot corner radius, and let's give it a corner radius of like 12. I think that's the default. Run this one more time and see how that looks. And then we will hop back into our Uber map view and adjust the frame of our map to fit the annotations with the card presented. So let's see. Coffee lovers. Okay, I think we might have to place it after we set up the background. So just move that corner radius modifier after the background, guys. where you put the corner radius in relative to the background actually matters. So this is now saying, hey, this has a background of a white color, and then we're going to apply a corner radius to that background. So one more time. Coffee lovers, hit that, and beautiful. It's very slight, but there is a corner radius there, okay? You guys could increase this to maybe say like 16 or something to make it more visible if you like. We do have this nasty spacing here at the bottom. So to fix that, we can go back to our home view and just go on this Z stack that we have here and go down and say dot edges ignoring safe area dot bottom. So this is going to tell the interface builder to ignore the bottom safe area, and this card will fill out this spacing here for us pretty nicely. And you can see that our corner radius is showing up there pretty well. So this is looking good. Let's just go ahead and test this out and see what our interface looks like now. So let's let this guy build, and then we are going to move on to adjusting our map view frame to fit the annotations with the card view presented. So let's see. We are going to go back through and select the location. Coffee lovers. Okay, that looks better, but we do need a little bit more spacing. So we're just going to give this guy some padding on the bottom edge. So if we go back to our ride request view, just put that padding before we set the background, and that should do the trick. So sometimes, guys, you just got to play around with this stuff in SwiftUI. You know, there's a lot of different ways of accomplishing the same thing. And if you guys can think of a better way to do this, feel free to try. But I think this is going to give us exactly what we want. Now, since we're doing it before, I think that should work. Perfect. That looks great. So let's actually give it a tad bit more. Let's make it like 24. And not 100,000, 24, whatever. Okay, so we got 24 pixels of padding there. Now we are done with setting up our presentation logic for this card view. Let's move on to adjusting the map frame to fit our annotations when this card view is presented. So lucky for us, guys, Swift gives us a way of solving this issue pretty easily. So we can hop back into our Uber MapView representable class, and we're actually going to remove the line of code where it says show annotations. That's not what we want. So we're going to just delete that line in the add and select annotation guy. And we're going to adjust our map view to make it fit the polyline and where the polyline ends up. So back in your configure polyline function, after we add the overlay, we're going to say self.parent.mapView.mapRect that fits, or sorry, we're going to create a property for this. We're going to say let rect equal maprect that fits route.polyline.bounding maprect. And then we're going to add a comma, and we're going to say edge padding dot init, and we're going to say top, and we're going to give it 64 pixels of padding on the top, 32 on the left, 500 on the bottom, and 32 on the right. So the height of this card is about 500 pixels. Like, I've sort of mapped it out before and figured out that it's like 500 pixels of height. So basically we're going to give the map view a bottom padding of 500 pixels, top of 64, left of 32, right of 32. So it's just going to shrink our rect to fit this, or the frame of the map view to fit when this card is presented. And then we just need to say self.parent.mapView.setRegion. And we're going to create this MK coordinate region and use this rect option here. And rect is just short for rectangle, guys. And then we're going to say animated is true. So let's go ahead and run this one more time. And we should notice that our map view now adjusts based on these parameters to fit all of the annotations and the polylines with the the padding that we added, which is based on, the height of our card. So let's see what we got. Let's go. Coffee lovers. And come on. There we go. Look at that, guys. Let's go. Right? So we have our card presenting now, and we have our map view adjusting its rect or its frame to fit everything we need it to. And if we click that back arrow, boom, it goes right back to its original state. And this looks absolutely incredible, right? This is a super responsive app. Our code is super, super clean, super concise. And I'm excited about this, man. I'm proud of myself for building this. You guys should be too. Let's go ahead and see if we can go to a different location just to see what it looks like. Let's go to Pete's Coffee, right? Ooh, man, check that out. Ooh, we got a problem. We got a bug. Let's see. Let's get out of this and see what happens when we do that again. So let's see. Pete's Coffee. Okay, it's good now. It might have just been like a one-off thing. Let's try to go to Starbucks. Ah, man, we got a bug. It's keeping the original polyline. So we're going to figure out how to fix that in another video. I'm just pretty pumped about the fact that we got this working at this point. And the next step after that is we need to configure this request ride view with actual data, right? So we need to drop in the location for where we're actually going. We need to get like the time it's going to take to get us to that location. And we need to create like an actual data model for these ride types, create a pricing model and all that good stuff. So we've come far, but we still have far to go. We are really getting this app to come together now, and it's looking absolutely incredible. So I hope you guys are excited. We'll see you in the next module. Peace. What's going on, guys? Welcome back. Hope you are doing well. In our last module, we went over the presentation logic for our ride request view and how to adjust our map view frame to fit our annotations. But while doing that, we noticed that we have a bug. So I'm just going to go ahead and recreate that for you one more time. So if I search for a location, so I say coffee lovers, right? And I click that, it generates my polyline to that location just fine. And if I exit the map view, everything works just fine there. But we noticed that if I were to select a different location, like let's say I select Pete's Coffee now, we notice that it somehow holds on to that value of the previous polyline that was generated. So this is going to be a pretty simple fix. Basically, it's happening because we never set the selected location to nil. So basically what's happening is once we select another location, it hits this location selected state and it's holding on to this previous value of selected location coordinate. And while it takes time to figure out the new route to the next place, then it draws the polyline to that next place. So if you guys want to see this happening a little bit more clearly, just go ahead and add a print statement to this guy right here. And in the if let statement, say print coordinate is, and then let's just go ahead and print out our coordinate. Coordinate. Okay, my autocomplete is being mean. There we go. And we're going to see that it'll print the coordinate of the first place and then generate the polyline to the second place and then print out those coordinates as well. So to solve this problem, it's pretty simple. We just have to make sure that whenever we exit our our location selected state, we set the selected location to nil so it doesn't hold on to that value. So let's go ahead and see this bug working more clearly. So we're going to say, oops, what did I just do? There we go. All right, so I'm going to say coffee lovers. And you're going to see that, okay, we get this guy here, right? Selected location coordinate is 37.321 and negative 121.826. And that works just fine. So we exit out of there, but the problem is that selected location coordinate is still equal to this guy. We never set it to nil and essentially wipe it out. So then when we go here and go to a different location, I'm going to select Pete's Coffee. you guys notice this is where we notice the problem, right? So it's holding on to this exact same coordinate that we see up here and redrawing that annotation. And then this is the new stuff that we get right down here. So that's why that's happening. So like I said, the fix is pretty simple. We're going to go into our MapView action button. And here in our, when we, the MapView is like in this state, location selected, we're just resetting it to no input. What we want to do is actually get access to our view model here and set that property to nil. So I'm going to go up to the top, and because we have an environment object for that view model, it's a location search view model, we can get access to it across multiple surfaces in the app, like I said before. So we can see where this environment object is really coming in handy. So now I can go down here and I can just say view model dot selected location coordinate equals nil. So now every time we exit this location selected state and we go back to the no input state on our map view, we sort of wipe out that previous value. So let's go ahead and run our code once more, and we're going to see that that bug is no longer happening. So that's an awesome example of some debugging, guys. I hope you guys understand the problem and understand the solution. And it really just goes to show you that you have to do every little thing in a program to make sure your app works properly. Someone once told me computers are dumb. We just have to be smart and tell them what to do. And I really love that statement. So right now we are going to Coffee Lovers, and that looks good. And now we'll go to Pete's Coffee, and we can see that it doesn't redraw that polyline to the previous location. So that's looking absolutely amazing, guys. That's an awesome bug fix. Really interesting and sort of difficult problem to solve. Took me a while to figure it out, but we got it done. So now, oh yeah, sorry. I accidentally commented out this stuff in our home view. So that's why the ride request view wasn't showing up. So that's my bad, guys. Let's go ahead and just run through this one more. I'm going to run through it one more time just to make sure the code is still working correctly when we're showing the ride request view. So if that was throwing you guys off, that's my bad. Sometimes I do stuff on camera, or sorry, off camera, and forget to change it back. I'm human, just like everybody else. So let's go and search for Coffee Lovers. Boom. So our card is showing up, and our map view is adjusting correctly. And you guys notice that does take a little bit of time, and that's because it takes time to process that directions request. So, and the farther away it is and the more complex it is to get there, the longer that directions request is going to take. So now let's go back. We notice that dismisses perfectly. And now let's delete that and go to Pete's Coffee, and everything is working smooth. Let's go. Bug solved. Give yourselves a pat on the back. That was a tricky one. But anyway, let's go over how to now start creating this data model for our different ride types as well as our pricing model. So next up, we're going to create our data model for our ride types and then use that data model to update our user interface to make it more dynamic. And we're going to hop into the models folder and create a new file. So it's going to be a Swift file, and we're going to call it ride type. And this is just going to be an enumeration, guys. So we're going to say enum ride type, and it's going to be of type integer, and then conform to this case iterable protocol as well as the identifiable protocol. So we're going to say case Uber X, case Uber black, and then, or we could just say black, and then we're going to say case Uber XL. We're now going to create an ID property. So we're going to say var ID int, and then we're going to say return raw value. And then we're going to create a description property as well. So basically what we need to do is get back some text for each one of these options. So we're just going to say var description string switch self, and we're then going to say case.uberx return uberx case.black return uber black case dot uber xl return uber xl, just like that. Okay, and then we're also going to get an image name for each guy. So we're going to say var image name string, and then we can just copy and paste this switch statement and paste it in there. And for this one, it's going to be uber-x. This one is going to be uber-black. And I couldn't really find an image for uber XLs, so we're just going to make that uber X as well. So this is all we need to get started with our data model, guys. So the reason I like using an enumeration here is just because it wraps all the values that you need into one structure, as opposed to creating like a struct, and then, you know, creating input parameters and stuff. We just get everything we need from this ride type enumeration. And this is also way easier to scale, right? So if you want to add more options, say like case uber comfort or something, it's really easy to scale, because if you try to build your project, it's going to throw an error in all of the places that you need to update your the properties associated with this ride type guy. So let's now go back to our trips view, or sorry, not the trips view, the ride request view, and utilize this data model to get some actual real data showing up here. So let's see, where is our guy for this? It's down here, payment option view. Here it is, right here. So instead of just looping through this static set of numbers, we're going to say ride type dot all cases. And for those of you who don't know, that's what this case iterable protocol helps us do. It essentially just helps you wrap all of your cases, your different options, into an array. So that's why we could then loop through that enumeration. So that's really, really helpful. Because we have an ID property, we don't need to use that ID \self guy. And now we can just say ride type in, or, you know, even just type in. And this is where this, I really, really love the power of enumerations. Now we can just say type.imageName, and this guy is going to be type.description right here. So basically, this is a quick breakdown of how this works. We're looping through this enum. So we go back to ride type, and it starts off at the 0 value, right? Because this is an integer enum, this basically just has a raw value of 0. This guy has a raw value of 1. Swift just automatically assigns that stuff for us, so we don't have to specifically say what it is. So it starts off as 0. So we're on the uberx case. And then when it goes to get the image name, it says, hey, we're on the uberx case, so we're going to return uberx. And then on the next iteration, it's going to be on uber black. So then the image name is going to be uber black, and the description is going to be uber black here. So like I said, this is super, super clean code. I really love the power of enums, and I use them all the time. And this is why I really love them. So now let's just go ahead and see if we can just resume our preview. So this way we don't have to just continually run the app like we were doing before, which was getting kind of annoying. Now we're just updating our user interface, so we can just utilize the preview. And guys, we are also going to be developing a pricing model to actually get some varying prices for trips of different distances. So let me show you what that looks like really quick. So for example, if I go to this Chevron, we notice that an UberX is $6, Black is $26, Uber XL is $11. But if I go to a different place that's farther away, say back to Coffee Lovers, we can see that I get a completely different set of prices. So we're going to build a pricing model out for this as well, just so you guys can get an idea of like how to do something like that. And we're going to base it off the distance of the trip. So this is already looking really, really good. Now let's go over how to select one of these options and then, you know, adjust our UI accordingly and get that really awesome like zoom effect there. So we need to know which ride type we currently have selected. So we're just going to go up here and create a state property. So we're going to say at state private var selected ride type equals dot Uber X. Perfect. Okay. So now we're just going to go back down here and add some logic using that selected ride type and comparing it to our type that we're looking at in our loop to adjust some things like the foreground color and the text color and stuff like that. So the first thing we're going to do is change this background color, right? So go ahead and just delete all this stuff. And you're going to say, let's see. Okay, so we're going to say color. And then you're going to open up another set of parentheses and close it out. So this is what it should look like right now. Then you're going to say type. Oops. So say type equals selected ride type yes dot system blue no dot system grouped background. Okay, so let's see if this works. Let's let our preview do its thing. And we should be able to select one of these and it will then have a blue background. So let's just let it do its thing. And then after that, guys, we need to modify the text color. So when it's selected, the text color needs to be white. And then we're also going to add that awesome zooming effect as well. So we can see that that's working nicely. And I can select. Oh, so we don't have the select functionality. Let's add that now. So I'm going to say on tap gesture. And then you're going to say with animation dot spring. And then you're going to say selected ride type equals type. So now it's going to give us this nice animation for when we select a type. So all we have to do is tap on it. And you guys can see that that is looking absolutely amazing. Now we just need to adjust a couple more properties. So we're going to go here and we're going to say dot foreground color. And we're just going to say type equals selected ride type yes dot white no dot black. And lastly, we just need to apply a scaling effect as well. So we notice that that's looking incredible. Now, just underneath one of those guys, you're going to say dot scale effect. And you're going to say ride type, or I keep saying ride type. That's my bad. You're going to say type equals selected ride type yes 1.25 no 1.0. So that should be the final piece of that puzzle. And we're just going to make sure that this is working correctly before we move on to actually populating this. Okay, so that looks a little bit off. We can just dial back the scaling a little bit. So let's say like 1.2. Okay, so I think what we want to do here, guys, is adjust the alignment of our VStack. So we can see here that like this isn't lining up on the leading edge. So on this VStack right here, where we have the description and the price, you can just go ahead and say alignment is dot leading. And that looks absolutely amazing, guys. And we notice that the functionality is working perfectly there. Everything lines up nicely. So that is going to wrap it up for this module. In the next one, we're going to be going over how to do not just our pricing model for trips that with different distances, but also how to get real trip data up in this header that we have here. So it displays the real location and actual times that it's going to take to get to your destination. What's going on, guys? Welcome back. In our last video, we went over how to get started with this ride type data model and then went over how to populate our view with that data model to actually configure some different ride types that the user can select. So we're going to start this module off by getting started with implementing our pricing model. So in order to do that, we're going to just keep building off of this enum. And we're going to create some properties and functions to help us compute the price for a particular ride and a particular ride type. So to start this off, I'm going to create a property called base fare. and it's going to be a double. And we're going to say switch self case.uberx return 5 case.black return 20 case.uberxl return like 10. So this is just a base fare that each ride is going to have, right? So just to hop in an Uber X, it's going to cost you $5. A Black, it's going to cost you $20. An XL, it's going to cost you $10. Now we're going to write a function to compute our price. So we're going to say compute price for distance in meters, which is a double, and it's going to return a double. So this function is going to help us compute the price for a trip distance, right? So say you want to take a trip that's 5 miles away. We're going to calculate the distance from the user's location to their destination location, and then call this function to help us compute our price. So really quickly, let's convert this distance in miles, distance in meters to distance in miles. So we're going to say let distance in miles equal distance in meters divided by 1600. Then we're going to say switch self, and we're just going to copy all these cases. And now this is where we're going to actually compute the price. So we're going to say return distance in miles. And for an Uber X, we're just going to say times 1.5 plus the base fare. And we're just going to copy this code, paste it here, and an Uber Black is going to be times 2.0, and an Uber XL is going to be times 1.75. So basically, guys, we're, like I said, going to need to compute the distance between the user and the destination location. And for example, let's say you hop in an Uber X and it's 10 miles away. It's going to say, okay, your trip cost is 10 times 1.5 plus $5. So that would be 15 plus 5. A 10-mile ride would cost you $20 in an Uber X. According to this pricing model, you guys could adjust these values however you see fit. This is just, a basic pricing model that we're going to be using to compute our ride prices. So the next step is going to be actually getting the user's location and calculating the distance between their location and the destination so that we can call this function and actually display the correct ride price here. This actually presents a pretty interesting problem, and that lies in getting the user location where we need it to call this function to display our prices. So let's go over what I mean by that. So if we go back to our ride request view, we ultimately need to call that function here somehow to get our ride price and replace this hard-coded value that we see here. So like I said, the problem lies in how to get our user location. So let's go over how exactly we're going to do that. So we are going to go to our location manager and set this up a little differently. So I'm going to go ahead and create a shared instance of this, and we'll go over why in just a second. So this is pretty similar to how an environment object works. So we're going to just say let shared equal location manager. So pretty similar to how an environment object works, we're just going to utilize this shared instance, and it's going to allow us to use it across multiple surfaces and utilize that same instance of this object. So right now we're initializing this in our Uber MapView representable, right? So we're saying, hey, this is our location manager. We're going to change this to location manager.shared. And now we're going to go back to our home view, and we're going to listen for some updates on this location manager. So really quickly before we do that, we need to set this up a little bit differently. We're going to add a publish property here for our user location. So I'm going to say var user location is CL location coordinate 2D. And then here is where we're getting our user location. And basically I'm going to just change this guard statement to say guard let location equal locations dot first else return, and then say self dot user location equals that location, and then we stop updating the location there. So you guys might be wondering, hey, why are we using this location manager to do this? We need to say dot coordinate. And the reason for that is because the only other place in the app we have the user's location is in this MapView representable class, and we don't want to publish any values from this class. This class is mainly just supposed to listen to updates on other things. We're not supposed to update anything else from here. Like you notice that we're not updating the map state anywhere here. We're just performing functionality and listening for updates on the map state. And that's because you'll end up with a nasty retain cycle that's going to really damage the performance of your app. So let's see, what's our problem? Location manager.shared. Did you mean to use what this? That shouldn't be a problem. Let's go back to this location manager. Oh, we need to say static let shared. So this static declaration, like I said, is very similar to an environment object. And this is how we're going to utilize this guy in order to get our user location. So we're going to go back to our home view. And we're going to use this onReceive method. So I'm going to go down here at the bottom of my VStack and say .onReceive. And we're going to say location manager .shared $user location. And then hit enter on that next guy and then just say location in. And let's just go ahead and add a print statement. We're going to say if let location equals location, print debug user location in home view is location. Okay, so let's just hit Command B to see if our project builds. And if this seems confusing right now, guys, don't worry. I'm going to break it down in detail before we move on to the next module. I'm going to go over why exactly we're doing this one more time and how everything works once again. So it looks like we have an error somewhere. Okay, nope, our build is succeeding, so that looks great. So let's just go ahead and run our application and see if we're getting this print statement back, right? So that will mean we successfully passed that user location into our home view. And then from our home view, we're going to create a view model and be able to use that as an environment object to use it in our ride view or ride request view. So we can see here that this is great. We're getting our user location in our home view. Now, like I said, the next step is what to do from here is we need to actually pass that location to a different place. And we're going to be doing that through the use of a view model so that we can read that location in our ride request view to ultimately compute our price. So the next step, guys, is pretty simple. We're just going to add that environment object of our view model to our home view as well. So I'm going to say environment object var location view model is our location search view model. So now we can add a property to this view model here and then pass this user location from our home view to that view model to ultimately help us compute our price. So let's see. What are we going to do? Location search view model. Right, so here we're going to create a property for our user location, and that's going to be a CL location coordinate to D. And then back inside of our home view, where is that? We're just going to say view model dot user location equals location. Right, so now we have access to that in our view model. And now we can go back to that location search view model and write a function to help us configure our price. So really quickly, let me get something open in my code. Right, so now we have all this stuff here. Let's go and create another helper function. We're going to say func compute ride price for type, which is a ride type, and it's going to return a double. So then we're just going to say guard let selected location coordinate equals selected location, or we can just call this coordinate rather, equal selected location coordinate, else return. And then we're going to say guard let user location equal self.user location else return. And now we're going to compute the distance between these two guys. So we're going to say let user location equal CL location with a lat and a long. And we're just going to say user location dot latitude and then user location dot longitude. Just like that. Then we're going to say let destination equal CL location lat long coordinate dot latitude coordinate dot longitude. And then Swift has this awesome functionality to help us compute the distance between 2 points, just like that. So we're going to say let trip distance in meters equal user location dot distance from destination. And then we're going to return type dot price or return type dot compute price for that trip distance in meters. So that is magic right there, guys. So I'm going to go over an explanation of that one more time. Like I said, don't worry. Here we can just return 0.0 and 0.0. We have to return something in this function. So these guard statements need to return like a default value. So now we're going to go over how to use this function back in our ride request view in order to get the price. So we're going to need an environment object here as well. Environment object var location view model is our location search view model. And now we're going to be able to call that function from here or through the use of that view model in order to generate our price. So let's go here and I'm going to say location view model dot compute ride price for type and pass the type in. Bam. That is freaking solid right there. So we actually need to make this a text component. So we're going to just cut that and use some string interpolation, and we're going to put a $sign before it for now. We're going to do some currency formatting here in just a little bit. Let's just go ahead and run this, guys, to see if it works. I'm super excited to see if this works, man, because that was some coding magic right there. And like I said, guys, keep iterating to you. I'm going to explain it in detail because I know it's a bit confusing. Let's see. Why is this? Okay. We can rename this to like user coordinate and then say user coordinate there. We can't rename these things twice or name them the same things. So this is our user coordinate, and let's just call this like dest coordinate to make the naming a little bit more clear. And then we're going to say dest coordinate right there. Okay, now let's run this. Let's go select a location and let's see if our price is showing up. And I think this is going to work, and I'm going to be super excited if it does. Man, keep getting errors. Okay, I believe we have to call this location view model. Yeah. All right, third time's the charm. I think that's the third time trying to run it. So let's see if this bad boy works, man. We've come a long way and we're almost done with this little piece of functionality here. So app is building, let's go, come on. We don't have all day. All right, we're up and running. Let's see what we got. All right, moment of truth. Coffee lovers. Bam. Okay, awesome. So the numbers look super ugly right now, right? But that's okay. We are getting some, our price model is working. So that's absolutely amazing, guys. You should be super excited about that. This is really starting to come together. So let's go ahead and just introduce like a currency formatter in our extensions so that we can format these currency values correctly. So I'm going to go to extensions and let's see. We're going to create a Swift file and this is going to be called double. So we're going to create an extension on a double in order to convert it to a currency. So I'm going to say extension double, and I'm going to say private var currency formatter, and I believe it's a number formatter. And we're going to say let formatter equal number formatter, formatter dot style or number style equals dot currency. Yep. Formatter dot minimum fraction digits equals 2. Formatter dot maximum fraction digits equals 2, and then we're just going to return the formatter. And now we're going to use that formatter in a function here. We're going to say func to currency, and we're just going to say return currency formatter dot string from or string for, and then say self. And this needs to actually give us back a string. So this needs to return a string, and if this for some reason doesn't work, we're just going to return a blank string. So now we can go back into our ride request view, and we can delete this string interpolation that we have going on, and we can just go here and say dot to currency now. So that's super smooth, guys. So now it's going to give us back a currency value, and anywhere you can reuse that that function anywhere you have pricing in the app. That just helps you convert a double value straight into a price with the correct formatting and all that good stuff. So let's just go ahead and see if this bad boy is working, and that's going to wrap it up for this module, apart from the explanation and the breakdown that I'm going to give you guys. So one more time. So like coffee lovers, and okay, that looks amazing, right? So it starts off as like 0.00, and that's okay. You know, it looks okay. This is just looking absolutely beautiful, and the pricing model is working great. So that's going to wrap it up for this video, guys. If you feel comfortable with that, feel free to hop to the next module. If not, I'm going to go through an explanation. So the whole problem started with us needing the user location. And the reason we need that is because we have to calculate the distance between the user and the destination location so that we can use that price function that we created in our ride type to compute the price. So basically the distance in meters is unknown right now, right? It's going to depend completely on where the user wants to go. So that's why we're using it as an input parameter here, because we're not going to know the value of this until we call this function. So this compute price function just converts the distance into miles and then goes through some calculation to help give us back a price. So next up, we had to get our user location, right? So we did that through use of the location manager. So there's a couple things we did. We introduced this shared instance, right? And that's because we want to utilize the same instance of this location manager across multiple surfaces in our app. And you're going to see as this app starts to scale and you start to introduce more functionality, how this really comes in handy. The same way we've seen how much those environment objects have helped us out, right? So this is the same exact principle. It's just a different way of introducing the same concept. I'm not sure if you could make this location manager an environment object or not. You may or may not be able to. You probably could, since it's conforming to this observable object protocol, but this is just a different way of accomplishing the same thing. I like showing you guys different ways of doing things, and you can pick which way you like better, and it also just helps to see things done in a different way. It might help you understand something better. So then we created this published property for this user location here. And we set that property down here, and then we stop updating the location. Because if you guys remember, we don't want to have the app repeatedly give us back that location and be pinging for the user's location, right? So why did we do it here and not in the Uber MapView representable? And like I was saying before, this class is not supposed to publish values anywhere. It's really just supposed to observe things, right? So that's what we're doing with like this map state and this location view model. You guys notice that we're not setting any properties on the location view model here. We're not changing the map state here. And that's because it would create this nasty retain cycle. So here's what would happen. Let's say I updated a property on the location view model. I'm also observing this, right? So I would update something on the location view model, and then it would trigger the observer and the listener relationship, and it would send that notification back to this, and then it would update it again, and then send it back to it again, and then update it, and it would just be this really nasty retain cycle. So that's why we don't want to update anything from this class. So you might say, hey, well, we have the user location here. Let's see if we could pass it up into our, our home view where we need this guy. Bad idea. Don't do that. So we do it through use of our location manager. And we did it through the use of this onReceive method. So basically this allows us to execute some code when we receive a value from some publisher, right? So we're utilizing this location manager shared guy, right? We initialize it, I believe in our Uber MapView representable just to get it going. I'm not even sure if we need this. Let's see if we can comment that out and still build our project. I think we could. The whole purpose of putting it here was just to get it initialized so that it could request our user's location and grab it for us. But now I think we're using it since we're using it in the home view, we should be good to go. So basically guys, we're just listening for when this user location property gets set. And when it does, then from here in the home view where it's okay to update things on a view model, that's where we update the user location property that we created on the view model. And on this view model, we then have this function to compute the price, right? And here is where we actually get the distance between the user's location and their destination location. And then we call that function based on the ride type that we pass in, right? So that is just absolutely incredible code right there. So we know that we're going to have access to the type back in our ride request view, right? Because we're looping through these individual ride types. So we get access to the type in this closure here, right here with this type guide, because we're looping through all this stuff. And this is where we need the price, right? So then we can simply just say, yo, compute the price for this particular ride type. And it computes the price for each one and displays it in our user interface. So, yo, I'm not a wizard, but I'm pretty damn close, man. And I hope you guys understand that. And I hope that breakdown really enlightens some understanding for how this stuff works and how to really pass data around in a SwiftUI application. It can get pretty complex, but the more practice you get, the better you guys are going to get at this stuff. And this app is a great example for you to have to look back on. And, I highly suggest trying to rebuild this app yourself multiple times until you can get it from start to finish on your own. That's how you're going to recognize that you have really mastered these concepts. And the first couple times you're probably going to have to, or you're definitely going to have to refer back to this code, but that's okay. That's really how I upped my skills as a developer, was rebuilding projects I went through tutorials for on my own until I could do it by myself. And you guys might even find ways of making this better than I did, because you might think differently than I do. But anyway, guys, that's my explanation for this. In the next one, we're going to sort of finish up this ride request view by getting actual trip data in here and displaying the title that we have and then computing the time that it's going to take to get from the user's location to our destination location. So get excited for that. We will see you there. And welcome back, guys. Hope you are doing well. In this module, we're going to be going over how to get the necessary trip data or ride request data that we need into this ride request view. So we pretty much just need two things. We just need the name of the selected location, and then we're going to calculate the trip time for the selected location from the current time, and then we're going to calculate how long it's going to take to get there, and then display the drop-off time or expected drop-off time. So there's a couple things we got to do that. So basically, we need access to the title of the location that we selected. Right now, we're just populating this selected location coordinate when the user selects a value, right? So we went down here and we said, hey, select this location. It searches for the location and populates it with a coordinate. So we're actually going to create a data model that's going to include both a title and a location coordinate for the destination we want to go to. So let's go ahead and start off by doing that. So in my models folder, I'm going to create a Swift file, and it's going to be an Uber location. And it's really just going to have two properties, guys. Super simple. It's going to be struct Uber location. And we're going to say let title be a string and let coordinate be of type CL location coordinate 2D. So let's go ahead. I think, yeah, we have to import, I think, core location up at the top in order for it to recognize this. And we're going to use this Uber location guy in order to get the title that we need. So let's go ahead, and this is going to require some refactoring. So we're going to go back to our location search view model, and we are going to replace this guy. We're just going to call it selected Uber location, and it's going to be an Uber location. So now if we try to build our project, it's going to throw a bunch of errors, and we're going to go through and go how to and fix those first before we actually utilize this Uber location in order to get the title into our ride request view. So first one's going to be down here, and we're going to say self.selected Uber location equals an Uber location. And if you guys remember, we have access to the title through this local search completion. So we can literally just go here and say local search.title. And then we have the coordinate after we completed our search. So there's our coordinate guy right there. So that looks absolutely beautiful. And now we need to modify a couple other things. Let's see. Let's just try to build it again. Okay, so this is going to throw an error, and we need to just say selected Uber location dot coordinate right there, and everything's going to be fine because we still have access to the coordinate. We just created a structure that includes a title and a coordinate. So let's see. Oh, we need to add a question mark after selected Uber location. And let's try to build this again. And I believe we're going to get an error in our Uber map view representable as well. But let's let it build, do its thing, and we'll see where it yells at us, and we'll go over how to fix it. Okay. Map view action button. Okay. So here we just need to set the Uber location to nil. So we're going to say self or view model.selected Uber location equals nil. And then let's try to build again. It's kind of annoying that it's not giving me a full list of the errors, but Xcode just does that sometimes. Sometimes it just goes one by one. But I believe the next error is going to be thrown in this Uber map view representable class. So let's see. Yep. Okay. So here, this is going to be super simple. We just say if let coordinate equals selected Uber location question mark dot lowercase c for coordinate. And we can remove this print statement as well, and this guy up here. We don't need those anymore. So that's our refactor, guys. And now if we build our project, everything should be just fine. And now we'll be able to actually use that title in our selected Uber location and pass it into this ride request view. So let's go to our ride request view. And you guys notice we have access to our location view model here. So right here, we just need to use an if let statement for this text property. So we're just going to say, let's cut this out. We're going to say if let location equals location view model dot selected Uber location, and paste that back in there. And now all we got to do is say location dot title, right? So that looks awesome. Now let's actually go ahead and run our code to see if this works, and then we'll go over how to calculate the time from the user's location to their destination location. And then that's pretty much going to wrap it up for that ride request view, I believe. And let's just go wait for this to run. So now basically, guys, anytime you select a location, it should populate that with the name of the place you're trying to go to. So let's see, coffee lovers, select that. And you guys notice that it populates there beautifully, right? And then if I go back, I exit out, and let's maybe try to go to Pete's Coffee or something. You guys notice that that populates there, and that is just working beautifully. So the next step is going to be to configure this pickup and drop off time. So let's go ahead and just jump right into that. So we're going to go back to our location search view model, and we're going to add 2 more properties to this guy. We're going to say @published var pickup time, which is an optional string, and we're going to create a published var for the drop off time, which is also an optional string. So you guys might be wondering, okay, how the hell are we going to get these 2 properties? So we actually need access to the route that we calculated from the user's location back to the, or over to the destination location. So we're going to do a bit of refactoring here. We have access to that in our Uber MapView representable, where we have this function called get destination route. So we're actually just going to move this from here. So let's go ahead and cut it with Command X over to our location search view model. So get destination route. So it's from the user's location to this destination. And we are going to call this function through the view model back in our Uber MapView representable. So you guys are going to notice that we will get an error somewhere. So let's see, where did we call that function? I think it was something with a route. Yeah, generate get destination route. So we just need to say parent.viewModel, or sorry, I think it's location view model dot get destination route. And let's go ahead and indent that to make it look nice and pretty. And if you guys go ahead and build your project now, everything should work exactly the same. So we just extracted that function for generating or getting our destination route over to our view model. And the nice part about that is we're going to be able to use that function and with the route that we get back to help us configure our pickup and our drop off time. So I'm going to go back into my location search view model, and I'm going to write a function here called configure pickup and drop off times. Right, and this is going to be, it's going to take in a parameter of with expected travel time, which is double, and it's not going to return anything. It's just going to set those 2 properties. And this is going to be super easy to configure. So you might be wondering, how do we get this expected travel time? Well, guess what? We actually have access to that through this route. So we can just go here and say self.configure pickup and drop off times with route.expected travel time. So now we just need to add some code into this function in order to actually set those properties using that expected travel time. So we're just going to create a date formatter really quickly. So we're going to say let formatter equal date formatter, formatter.date format equals HH:MM space A. And then we're just going to say pickup time equals formatter.string from this date, which is right now. Anytime you do a date with just a blank constructor, it gives you the date at this exact moment. And then you're just going to say drop off time equals formatter.string from date plus expected travel time. It's that easy, guys. So Now let's just go ahead and figure out how exactly we're going to use these published properties. So they do get published. And if you guys remember, we have this environment object of our location search view model on our ride request view. So all we need to do is configure or replace these hard-coded values with the pickup and the drop-off time. So here I'm just going to say location view model dot pickup time. And if it's not there, just give it a default value of a blank string. And then here, I'm going to say location view model dot drop off time or blank string. So ideally, that should wrap it up, boys and girls. Let's go ahead and see if this works. And if it does, we are going to move on to adding dark mode support to our app, which is going to be super fun and make our user interface super dynamic. And it's going to be absolutely amazing. So let's just go ahead and make sure this is working before we move on to that next module. By the way, guys, this app is awesome, right? Like this code is awesome. This app is awesome. I think I'm doing a pretty damn good job of explaining everything to you guys. This stuff is hard, you know? If it's confusing, that's okay. Just keep going through it and watch these videos to get my explanations. And if you have questions, drop them in the comments. I always respond. So let's go and see coffee lovers. Ooh, yes, let's go. Yeah, that's right. I'm working at 11:24 p.m. And oh man, we have a little bit of a bug there, right? It looks like it's constantly updating our annotation. So we're going to figure out how to fix that in another video. The most important thing is that we have successfully configured this guy with ride data, and it's looking really, really good, guys. So in the next one, we're going to fix this bug and then maybe do some refactoring in our code and then add dark mode support. So get excited for that. We'll see you there. Peace. What's going on, guys? Welcome back. In our last video, we really got that ride request view wrapped up and it looks amazing. However, we notice with this new functionality we've introduced with that pickup and drop off time, it was creating this nasty bug and we're going to see that recreated in just a second here. And it's basically repeatedly adding a MapView annotation over and over again. So if you guys remember, I talked about getting a retain cycle somewhere, and that's exactly what's happening here. So let's just go ahead and take a look at the bug one more time and then go over how to fix it. So you guys will notice that it's constantly adding this map pin annotation, and that's not good, right? So we're going to actually add a print statement to see what the hell is actually happening here. And basically, guys, it's because we're in this location selected state and we are publishing some properties through use of this, what's it called? Really quick, let me find it. This get destination route guy. So when we call this function, it's configuring those pickup and drop off times, which is setting these two published properties, and it's creating a retain cycle. So basically, these two guys are getting published from the Uber MapView representable, and then because we're publishing from there, these properties are getting published. The Uber MapView representable then observes those changes and then updates them again and observes the change it's making itself. So that's this nasty retain cycle that is not good for our app, right? So it's really just going to damage your performance, cause memory leaks, and all this nasty stuff. So it's actually pretty easy to fix. I couldn't really think of another way of doing this, but I did come up with a fix to solve this retain cycle issue. So let's go back to our Uber MapView representable, and just to see this happening in real time, let's just go ahead and call or write a print statement saying debug adding stuff to map. And let's just go through that process again, and we're going to see this print statement just showing up over and over and over again. And basically to fix this, guys, we're going to add another state to our map view. And pretty much once we add the polyline, we're going to get out of this location selected state so it doesn't keep doing this stuff. Pretty simple fix. Once you figure out what the problem is and how to solve it, right? It's relatively a complicated or complex fix because all of these things communicating with each other in this app has gotten pretty complex, right? So let's just go ahead and say coffee lovers, select that guy. And you guys are going to see that this just keeps on showing up, right? And that's bad. So in order to fix this, like I said, we're going to add another state to our map view. So I'm going to go here and I'm going to say case like polyline added, something like that, just to indicate that, hey, we've already added these annotations or things to the map, right? So now the beauty of this enum, once again, guys, is in what I talked about before, everywhere we need to adjust or everywhere this enum is being used, we're using switch statements. So it's going to throw errors in all of the places that we need to go and add this case to. And like I said, it just makes your app really easy to scale and add functionality to. So first place it comes up is in our MapView action button. So basically, guys, in this action for state, when the polyline is added, we want it to be the same as when the location is selected. So I'm just going to go here and say .polyline added. And then in this image name for state, guys, just go ahead and add a default case. I think I did this off camera. So we don't really need to get a bunch of different images or switch through the entire thing. So we can just give this a default case and just return the line.3.horizontal. And then we're going to try to build it again. And I think it's going to throw an error in one more place, and that should be back in our Uber map view representable. So let's just go here. And you guys will notice that in this update UI view function, we're switching through this guy. So let's see. Yep. So case.polyline added. And we're literally just going to do nothing in this state. This is just kind of like a state where we don't want it to do anything, right? So like we select the location and then we want to do all this stuff, but then we're going to transition it into this polyline added state where it's just not going to do anything. So it doesn't repeatedly keep adding the annotation and trying to configure that polyline. So you guys will notice this just kept going and going and going until it said, hey, we failed to get directions because you asked me to do it so many times. It got tired of us being shitty coders. So pretty much right down here, guys, we're just going to say with this configure polyline function, once we add it, we're just going to say parent.map_state equals .polyline added. And then there's one more piece of functionality we need to add. We just need to make sure that we still have our booking view or ride request view show up when we're in this map state. So we're just going to go back to our home view. And here we're going to say if map state equals location selected or map state equals .polyline added, then we're going to show this ride request view. And let's just go ahead and run this guy. And that should solve our bug. And then we're going to be able to move on to introducing our dark mode support for this app, which is going to be a lot of fun. It's always one of my favorite things to do, and be able to switch it in between light and dark mode and really just add that extra touch to your user interface and your user experience. Very important to do, guys, if you want to build a quality app. If you want to build bad apps, then don't do it. So we're going to say coffee lovers one more time, and let's pay attention to our console. And you guys can see that we literally just get that print statement back once, which is absolutely amazing. That solves our bug. And like I said, all we have to do is just add a map state to our enum to indicate that, hey, our polyline is added, and ooh, we have an issue that we need to solve here. So we got to go back to our map view action button. Image name for state, searching for location selected, and .polyline added. So that should solve that issue for us there. But I think here the action should still be the same. Yeah, it just doesn't have the arrow indicator. So the action works. Now we've solved the image name for that map state as well. So that's looking really good, guys. So now that we fixed that bug, let's go ahead and get started with implementing dark mode support. So let's go ahead and just take a look at what the dark mode is going to look like. So we notice we're going to change the background color of this guy. We're going to change the item background color of these options of this guy. The text is going to change to white. The button's going to stay the same, however, and this guy is also going to stay the same, but we're also going to introduce this dark mode support for the location search view as well. So let's just go ahead and toggle our app to dark mode right now to see what it looks like. It looks pretty bad. So go ahead and just hold down, click into the simulator, hold down Command-Shift-A, and that looks great, right? But you guys will notice this stuff does not. And if I try to find a ride, this looks absolutely terrible, right? So let's go ahead and figure out how to fix this stuff. So first thing is we are going to create an extension on our color. And we're going to go over why we do this in just a little bit, but it's essentially just going to help us access the color schemes that we're going to create in our assets folder. So let's get started by creating this extension on our color. So go to the extensions folder and create a new file. It's going to be a Swift file. And just hit next. Let it do its thing. And we're going to say this is color. And we are going to go here and create a struct called theme or color theme. And then we are going to create a struct or an extension on color. And we're going to say static let theme equal color theme. So now we're going to place a bunch of colors in this struct, and we'll be able to say color.theme.whatever, right? So let's go ahead and get started with that, and we'll come back and actually populate this struct with values. So we're going to go to our assets folder, and you're just going to right click in this little menu bar here, and you're going to say new color set. So let's call this guy primary. Oops. Or let's do the first one as just background color. So we want our background color to be white when we're in light mode, and we want it to be this like nice dark gray when we're in dark mode. So you guys will notice that I chose to implement this like I said, this darker gray instead of just a straight up black, because I think the darker gray looks a little bit better. Sometimes the like just the super dark black is just a little too harsh, and I don't really think it looks that great. It does in some apps, but you know, in this one I just chose to do it differently. And this is really easy to implement, guys. So just go ahead and toggle that this right side menu right up at the top there. And you're going to say show color panel, and then you can just go select this colored pencils like tab, and go ahead and just make it like lead. I think that's the one. Yeah, it's definitely lead. So it's the second one over from just like straight up black, or they call it licorice here. All right, so that looks good. Now let's see if we can go and add this to our color theme, and then we'll keep going from there. So let's go back to color, and we're just going to say let background color equal color background color. And we need to import SwiftUI up here. So how exactly does this work? So anytime we create a color in our assets folder, we can access it through using that raw string. So it's just background color. Make sure you guys spell everything correctly. So we have background color here. Now we're going to go and see how we can implement this. It's super, super slick. So first place I want to do it is in my location search view. So let's see. Location search views, location search view. And on this entire VStack, we're just going to say dot background, and then you can say color, and then you'll notice that we have this dot theme guy now, and then you can just say dot background color. And this is automatically going to adjust our background color based on whether or not we're in dark mode or light mode. So this is yelling at me, and I don't know why. So yeah, it shouldn't be. That's right, Xcode, you stop that. So let's I think running our app at this point might be quicker than the preview, guys. So let's just go ahead and run it and see what we get. So we are going to be on the iPhone 13 Pro here. I guess let me throw the completed app back into light mode for now, just so we can distinguish what's going on. So you guys will notice that like light mode looks exactly how we had it before. And then like, let me transition to dark mode live so you can just see what that looks like live. So that looks pretty slick. And Xcode is just taking its sweet time to build. Looks like it should be done soon. So yeah. But then we're really only going to have to create like 1 or 2 more colors, guys. We're going to, let me just go through and show you what we're going to do while we wait. Oh, perfect timing. As I was about to explain stuff, the app is launching. Okay, so this looks good. So that's cool. And this looks good now, right? And then let's go ahead and see what it looks like when we search for something. Oh, yes, check that out, baby. That looks awesome, right? So that's a super, super easy fix right there, guys. That's great. You do notice, however, that like these text fields are now kind of ugly, so we can fix that in a little bit. And also, you notice that if we select something, that this looks just absolutely terrible. So we need to fix this as well. So first of all, let's go ahead and replace this background with our color theme background to get started. And then we're going to figure out how to make these look a little prettier as well. So let's see, ride request view. And I believe we just have this set to a value of white, which we're going to change right now. So yeah, background is white. We want it to be color.theme.background color, just like that. And once again, I don't feel like waiting on the preview. I think running our app is faster at this point. I have so many things running on my computer, guys, that it's kind of just like pooping its pants. So it's a little laggy, and you know, that's my bad if, you know, it's causing problems for you in watching the video, but it's also annoying as hell for me to code with, you know, all that lag and the stuff being this big. But hey, we do what we got to do, right? So let's see. Let's go ahead and just request a ride again and see if that looks better. So this looks great. Okay, so that definitely looks way better, right? We just need to replace the, what's it called? The background color of this. And we also need to create like a text color object. So let's go ahead and do that now. So let's see, back to assets. And I'm going to create another guy. So another color set. And let's call this secondary background color. Cool. So any appearance, we're just going to make it, or the light mode essentially, we're just going to make it like a super light gray right there. And for dark mode, we're going to just make it like this, this like iron color, or potentially, let's do this tungsten. I think that's better. So now we're going to go back to our extension file, and we're going to say let secondary background color equal color secondary background color. Boom. And this is all you have to do to add colors, guys. We are accessing all of them through this theme static object, which is an extension on our color class. So this is super, super smooth implementation here. Let's go back to our ride request view, and we got to change some stuff up. Let me toggle out of this menu, and I'm honestly just going to close the preview at this point. It's virtually useless. So now we have some more room to see our code. So here we're going to replace this background on, yeah, we got to do it on our payment option view as well. So let's just go ahead and say color.theme.secondary background color. And we're going to do the same thing on this guy. So background color, it's either system blue, or we're going to say color.theme.secondary background color. But we do have to like change up the way we type this. So I'm just going to retype it. I'm going to say background type equals selected ride type yes. Then we can just say dot blue, no color dot theme dot secondary background color. Okay, so, and then let's just delete this line of code here. And the last thing we have to do is change the foreground color, right? So if we select ride type, it's white. If not, it's black, but that only works in light mode, right? So you can see here, if I toggle my app back into light mode, this is when the foreground color is black. But we need to just add some logic in there to make sure it uses our color theme. And we need to add one more color to our color theme. So let's add a new color set, and we're just going to call this guy primary text color. And this is super simple. It's just white in any, or sorry, it's black in any appearance. So it's just going to be straight up black, and then it's going to be straight up white in the dark mode. So that looks good. Now let's just go back to this ride request view and fix our logic here. So type equals selected ride type. Yes, we always want it to be white. And then no, we're going to replace .black with color.theme. And we actually need to add this to our color extension. So I'm going to say let primary text color equal color primary text color. Get out of this guy. I don't think we need it anymore. Go back to ride request view. And then here, where did we leave off? Color.theme.primary text color, just like that. So now we'll run the app one more time. Go through requesting a ride, or selecting a location rather. And I believe that should take care of everything. And that is as simple as that to introduce dark mode support, ladies and gentlemen. If you guys know how to do that the right way, it's actually so easy, and it adds so much like aesthetic to your app. You know, like if your app doesn't have dark mode support, people use dark mode a lot now, and not only that, but they toggle between light and dark mode. So it's incredibly important to introduce dark mode support into your app if you want your users to have a good experience. This is straight up professional code, man. We're not playing around. So let's toggle it to dark mode. Say coffee lovers. And it's just taking a bit to load. I think that's just going to be a simulator bug. Let's just try to search for it one more time. Yep, there we go. So that's absolutely perfect, guys. You guys notice that this is working in dark mode beautifully. We see that the text is white even when it's not selected. And if I were to toggle this back into light mode, we see that it changes back to black. And that is going to wrap it up for our dark mode support, guys. Hope you enjoyed this module. Thanks for watching.